Welcome students. In this class we are starting our study on trigonometric equations. Now foremost we will have to know what is a trigonometric equation. So let me define it. So the definition is as follows. Trigonometric equation is an equation involving one or more trigonometric ratios of unknown angles, right? So an example of a trigonometric equation would be sin theta is equal to 1 over 2. This is a trigonometric equation. Sin squared theta negative 2 times, say, sin theta positive 1 is equal to 0. This is a trigonometric equation. So in a trigonometric equation, first and foremost thing is that you need to have trigonometric ratio, either 1 or more than that, and that there should be a equality sign connecting the left hand side and the right hand side. Okay, so having mentioned that, let us see an example. So I would like to take this to be an example. Sin theta is equal to 1 over 2. If we were to draw the graph of sin theta is equal to 1 over 2, there are two parts here. One is left hand side and right hand side. First let me draw the graph for sin theta. Say y is equal to sin theta. So that graph would be roughly in this fashion. Right, it would be a wave, right? Now if I were to draw the graph for y is equal to 1 over 2, then that would be a constant line. Okay, this is the rough graph. Now if I were to ask you find the point of intersection of the line y is equal to 1 over 2 versus the curve, sine curve y is equal to sine theta, what would you say? You have a point of intersection here. Let me use this pen. You got a point of intersection here, 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 and that subsequently you're going to have infinite number of points of intersection of y is equal to 1 over 2 versus y is equal to sine theta, right? So if I were to ask you find all the points of intersection, that is called as the general solution. Have that in mind. So what is the meaning for the general solution? If someone were to ask you find all of these points of intersection, clearly we know there are infinite set of points where y is equal to 1 over 2 is intersecting with the curve y is equal to sin theta. So to get all of the solutions is called as a general solution. Number 2, there is another solution that is called as the principal solution. Now what is the principal solution? Principal solution is to obtain all of the solutions that are given in the interval 0, 2 pi. So this is a very important understanding, because in all of the questions you will either be asked to obtain the general solution or the principal solution or both. So just to reiterate, the principal solution is found in the interval, closed interval 0, open interval 2 pi, right? And the general solution is nothing but to obtain all of the intersecting points of, in this case it's y is equal to 1 over 2 and y is equal to sin theta. So that is what is of critical importance in understanding trigonometric equations. So having mentioned that, let's move on, students. Okay students, having defined the two terminologies, the general solution and the principal solution, the most important question now is how are we going to obtain the principal solution? Say for example for sin theta is equal to 1 over 2. Now if we were to consider the graph Now clearly there are 2 points of intersection here. So as I mentioned, there is a point of intersection here, there is a point of intersection here. And the graph is flowing from 0 to 2 pi. This point is going to be 2 pi, right? We already know that. So between 0 and 2 pi, there are 2 points of intersection. Now clearly we know that when sine theta is equal to 1 over 2, theta value is going to be pi over 6. So this value, this point of intersection is going to be pi over 6. Now the next important question is, what would be this value? In other words, what would the value of theta be for this point of intersection? Now clearly we know that it's going to be 5 pi over 6. Now the question comes is, what if they would have given us, instead of the sine curve, they would have given us some other function? How are we going to extract the value of theta? Because it is imperative that we obtain the value of theta. That is obviously the principal solution, right? The point of intersection. But if in case we were to encounter functions which aren't too familiar, then extracting the point of intersection would become a challenge. In other words, extracting the value of theta would become a challenge. That would be at times a little bit tougher to crack. So what I wish to do here is, I would like to give you an alternative technique without the use of graphs to obtain the principal solution. Now foremost, this particular method has got 3 steps. Now the first step is, whatever be the equation given to you, take the modulus sign and then write that as sine alpha. Okay, so mod of 1 over 2 is going to be positive 1 over 2. Now step 2 is, find out where exactly this particular value is located. In other words, in which of these quadrants. Now clearly I mentioned to you that we use the concept of CAST, C-A-S-T. All ratios are possible, sine alone is positive. When I say possible, it means positive. So in the first quadrant all ratios are positive, second quadrant only sine is positive, third quadrant tan alone is positive, and in the last quadrant cos alone is positive. When I say cos, it means their respective reciprocals also will be positive here. Now clearly if sine alpha is equal to 1 over 2, it's a positive sign here, and that is possible only in the first quadrant and in the second quadrant. Okay, so that has been zeroed in. So in step number 3, the values, it is imperative that you know this, you have this in the corner of your mind. The values that theta would take would be given as follows. In the first quadrant, theta takes alpha. In the second quadrant, theta takes pi minus alpha. In the third quadrant, theta takes pi positive alpha. In the final quadrant, theta takes 2 pi negative alpha. So this is important. Now clearly we know that sine alpha is equal to 1 over 2, which is positive, and that occurs in the first quadrant and in the second quadrant. So if I were to write the solution, okay, clearly the principal solution, okay, for sine theta is equal to 1 over 2 is alpha and pi negative alpha. Okay, but clearly we know that alpha is equal to pi over 6 because sine 30 is equal to 1 over 2. So this is going to be pi over 6, and in this case it's going to be pi negative pi over 6, which is equal to 6 pi negative pi over 6, which is 5 pi over 6. Let's do another question, students. So we are given in this case sine theta is equal to negative 1 over 2. So step 1, according to step 1, we take the modulus of this value negative 1 over 2 and write it in this fashion: sine alpha is equal to 1 over 2. Now step number 2 is to find out where exactly we would get 1 over 2, and the sign has to be negative, right? So if I were to represent this by the popular CAST, C-A-S-T, sine is negative in the third quadrant and in the fourth quadrant, right? So step number, let me write that down here. Step number 3 would be to write that popular quadrant for theta. Now theta takes alpha here. Over here it takes pi negative alpha. Over here it takes pi positive alpha. Over here 2 pi negative alpha. Right? So since the value of sine is negative in the third quadrant and in the fourth quadrant, the principal solution is pi positive alpha and 2 pi negative alpha. But what is alpha? So alpha is going to be 30 degrees. So this is going to be pi positive pi over 6, which is nothing but 6 pi positive pi over 6, which is equal to 7 pi over 6. Now for this it's going to be 2 pi negative pi over 6, which is equal to 12 pi negative pi over 6, which is equal to 11 pi over 6. So therefore the principal solution is going to be 7 pi over 6 comma 11 pi over 6. So that is the solution, students. Let's move on. Students, let's do one more question. I would like to use the space over here. So imagine we are given this question. Say tan theta is equal to negative 1 over root 3, and we are asked to obtain the principal solution. So step 1 is going to be taking the modulus of this value. So we got tan alpha is equal to 1 over root 3, right? Now step 2 is where exactly tan is going to be negative. Now if I were to write the cast, clearly tan is going to be negative in the second quadrant and in the fourth quadrant, right? So step number 3 was going to be, let us find the theta value. So theta will take alpha in the first quadrant, pi negative alpha in the second quadrant, pi positive alpha in the third quadrant, and 2 pi negative alpha in the fourth quadrant. So clearly in this case we can easily obtain the value for theta, right? Now tan alpha is equal to 1 over root 3, therefore the value of alpha is equal to 30 degrees, right? So which is nothing but pi divided by 6. So therefore the principal solutions are going to be in the second quadrant pi negative alpha, in the fourth quadrant 2 pi negative alpha, right? So if I were to place in the values, so pi negative, theta is pi over 6 and 2 pi negative pi over 6. So let me use the space to write the final solution. So we have got pi negative pi over 6 comma 2 pi negative pi over 6. This is going to be 6 pi negative pi divided by 6 and 12 pi negative pi divided by 6. And this is equal to 6 negative pi would give us 5 pi over 6, and this is going to be 11 pi over 6. So this is the principal solution for the given question, which is tan theta is equal to negative 1 over root 3. So we will move on to the next one. Let's do another question, students. We are given cosecant x is equal to negative 2, right? And we are expected to find the principal solution. Now cosecant x is equal to negative 2, so this would imply 1 over sin x is equal to negative 2. Therefore sin x is equal to negative 1 over 2. So this is the understanding. So step number 1, we take the modulus of this and write it as sin alpha is equal to 1 over 2. Now step 2, we will want to locate the quadrant where sin x is equal to negative 1 over 2 occurs. In other words, where exactly sin occurs in a negative fashion, or in which of the quadrant sign becomes negative. So however you want to represent, you can make the representation. So clearly, if we were to apply the cast measure, we know that sign is going to be negative in the third quadrant and in the fourth quadrant. So having got that, let us go to step number 3 and find out the values that theta can take in these quadrants. In the first quadrant, theta takes alpha, or in this case x will take alpha. Second quadrant is going to be pi negative alpha. Third quadrant is going to be pi positive alpha. The fourth quadrant is going to be 2 pi negative alpha. Now clearly we know, since I've taken sin x is equal to modulus of negative 1 over 2, which is nothing but 1 over 2, we are actually dealing with theta to be equal to, or in this case alpha value is going to be pi over 6. Okay, so alpha is equal to pi over 6, because pi over 6 is nothing but sin 30, and sin 30 gives us 1 over 2. So therefore the principal solutions are going to be the third quadrant and the fourth quadrant. So that would be pi positive alpha and 2 pi negative alpha. So if I were to substitute the value of alpha, I would get pi positive pi over 6 comma 2 pi negative pi over 6, which can be rewritten as 6 pi positive pi over 6 and 12 pi negative pi over 6, which is equal to 7 pi over 6 comma 11 pi over 6. So this is our principal solution. Students, now it's time for us to obtain the general solutions. Now when sin x is equal to sin alpha, then the general solution is given as x is equal to n pi plus negative 1 raised to the power of n times alpha. Similarly, when cos x is equal to cos alpha, x is given to be 2 times n times pi plus or minus alpha. When tan x is equal to tan alpha, x is given to be as n pi plus alpha. Now subsequently, when sin squared x is equal to sin squared alpha, cos squared x is equal to cos squared alpha, and tan squared x is equal to tan squared alpha, the general solution is given to be as x is equal to n pi plus or minus alpha. So it's important that you have this in mind. Here you get only plus, here you're getting plus and minus, so have that in mind. To understand this concept, let us do a question. Imagine we are asked to obtain the general solution for tan squared x is equal to 1. Now before I could give you the solution, please do not write this as tan x is equal to root of 1. Don't do that, because you will end up with a solution that is contradictory to the very fact that tan squared x is equal to 1. So having mentioned that, so this is a no action. So we are given tan squared x is equal to 1 and we are expected to obtain the general solution. So what I would be doing, I would be rewriting tan squared x equal to 1 to be as tan squared of pi over 4, right? Pi over 4 is nothing but 45. So tan 45 is 1. Tan squared of that particular value, 45, will still be equal to 1. So I'm not doing anything different. Now this is similar to the one that we have studied. So you can clearly write that this is similar to tan squared x is equal to tan squared alpha, where the general solution is given to be as what? X is equal to n pi plus or minus alpha. So if I were to write here the general solution, hence the general solution is x is equal to n times pi plus or minus, what's the value of alpha here? Pi over 4, where n is an element of integers. So that is the solution. To be more precise, the general solution for the given question. Let's do this question, students. We are asked to find the general solution for sin x is equal to negative root of 3 over 2. So first what we will have to do is, to solve this question, it comprises of 2 steps. So step number 1, we will have to find the principal solution, and step number 2, we will have to then head on to find the general solution. Now let's execute step number 1, that is finding the principal solution. So to find the principal solution, we have got 3 steps, right? For the first step, what we would do is we would take the modulus of this quantity and write it as sine alpha is equal to root of 3 over 2, right? Now what would be the value for alpha here? Now clearly sine 60, right? Sine 60 is going to be root 3 over 2. So alpha is pi divided by 3, right? So having got that, next step number 2, we will have to know when exactly or where exactly sine takes the negative value. So if I were to apply the cast concept, C-A-S-T, sine is negative in the 3rd quadrant and in the 4th quadrant. So that will take us to step 3, where the first quadrant takes, where theta takes the value alpha, second quadrant is going to be pi negative alpha, third quadrant pi positive alpha, final quadrant, fourth quadrant is 2 pi negative alpha. Since we are basically concerned with the third and the fourth, the principal solution in this case is going to be pi positive alpha and 2 pi negative alpha. So this would mean pi positive, the alpha is pi over 3, and 2 pi negative pi over 3, right? So this is going to give me 4 pi over 3 and 6 pi negative pi, that's going to be 5 pi over 3. Now take one of these values. So clearly we can say that therefore this implies the principal solution is found to be as 4 pi over 3 comma 5 pi over 3, right? So that is for the principal solution. Now out of these two values, we can choose one of the value to be as alpha and then head on to obtain the general solution. So what I wish to do is, let me write that down, general solution. Now we know that when sin x is equal to sine alpha, the value for x is given to be as n pi plus negative 1 raised to the power of n times alpha, right? So that would mean my sin x in this case is going to be sine of, I have taken alpha to be as 4 pi over 3, so this is going to be sine of 4 pi over 3. Now sine of 4 pi over 3 is obtained because of the principal solution we have just received, or in other words we have just achieved. So I'm just taking one of these values. Now having obtained this, clearly we can hence obtain the value for x, which is going to be n times pi plus negative 1 raised to the power of n times 4 pi over 3. Now what is this? This is the general solution. So clearly you can put this in a box. So that is the solution for this beautiful question, students. We will head on to the next one. Let's do another question, students. This question is given to be as sine squared x is equal to 1 over 4. So what I'm going to do is I'm going to write this 1 over 4 as sine pi over 6, because sine pi over 6 will give me 30, right? Sine 30 is 1 over 2, but I need to produce 1 over 4, so just square that. So subsequently this is rewritten as sine squared pi over 6. So remember, do not transfer the square to the other side and write it as square root of 1 over 4. That is not going to be working at all. So this would mean this is of the form sine squared x is equal to sine squared alpha, which would mean x is equal to n pi plus or minus alpha. So hence the general solution is going to be equal to n pi plus or minus, what's the value of alpha? It's pi over 6, right? And n is any integer, so that is going to be the solution, and we can box the result. So we will move on to the next question, students. Let's do another question, students. In this question we are given cot x is equal to -1. Now we haven't seen anything involving cot, isn't it? But however we know that cot x is equal to 1 over tan x. So rewriting this, we are going to have 1 over tan x is equal to -1. Therefore tan x is equal to -1. Now to obtain the principal solution, actually the question wants us to find the general solution, right? So for that, as I mentioned to you, it involves two steps. One, we start off by finding the principal solution, and then we move on to obtain the general solution. So the steps for obtaining the principal solution is as follows. So step number 1, we take the modulus. So therefore we now have tan alpha is equal to +1. Now step number 2 is to zero in the quadrant. So we employ CAST. Now tan x is equal to -1. Where exactly tan is negative? Clearly in the second quadrant and in the fourth quadrant. Now step number 3 is clearly the possible values that theta can take in among in other words, x can take in this quadrant is as follows. Alpha, this is going to be pi negative alpha, pi positive alpha, and 2 pi negative alpha. So therefore the values for the principal solution is going to be lying in the second quadrant and in the fourth quadrant. So this would mean my alpha in this case, clearly we know that alpha is equal to pi over 4 here, right? Because that's 45. So that's going to be pi negative pi over 4 comma 2 pi negative pi over 4. So this is equal to 4 pi negative pi, that's 3 pi over 4, 8 pi and 7 pi over 4. So I will take one of these values for obtaining the general solution. So what I will do is I will take 3 pi over 4. Now we know that when tan x is equal to tan alpha, x is equal to n pi positive alpha. So this is the general solution. So in this case this would mean tan x is equal to, I'm choosing the first value, tan of 3 pi over 4, which would mean my general solution is equal to n pi positive 3 pi divided by 4, where n is an element in the integer, in the set integers. So this is the solution for this question. Students, the next topic we would be learning is known to be as number of solutions. Right, so we would have to extract the number of solutions that are occurring in the given equation. Now, this wouldn't be exclusively asked as a question, but it would form a part of another question. So, having mentioned that, it is imperative that you take note of this particular topic, and it is of critical importance. And having mentioned that, let us move on to do a question. Now we have been given sine 4x is equal to negative 1 over 2, and x is contained in 0, 2 pi. Right? Now, a point of observation. If you were to draw the graph of sine 4x, it would be a real challenge because this is a compressed graph. So what we would be doing is we would try to convert sine 4x into sine x, because we know the graph of sine x, right? If it were to be sine x is equal to negative 1 over 2, then it would be a cakewalk for us, because the graph of sine x is well known to us, but the graph of sine 4x, to draw it would be a real challenge. So having mentioned that, what I wish to do is I would like to convert sine 4x into sine x. Now, how are we to do that? So let us just start off like this. Now, this is given, right? Given that sine 4x is equal to negative 1 over 2. Now, the interval given for x is between 0 and 2 pi. Now, what I would like to do is I would like to take the value or the coefficient of x, which is 4, and then multiply it out. And that would give us 4 times x is contained in 4 times 0 is 0, 4 times 2 pi is 8 pi. So this is what I'm doing. Now, having done this, what I wish to do is I would like to now, let me write that down here. So sine 4x is equal to negative 1 over 2. So this is what I have got. Now the next step is I would like to take, let 4x be equal to theta. So if I were to take sine 4x is equal to theta, then that would mean I now have sine theta is equal to negative 1 over 2, where theta is in the interval 0, 8 pi. Right, now if you were to draw this, then the graph would look something like this. So 0 to 2 pi. So let me just draw the graph. So the graph of sine x is going to be like this. It's going to hit here and then move up and hit and then move up and then hit and then move up and then hit and then move up. Right, so let me give the coordinates now. So this is going to be 2 pi and then 4 pi and then 6 pi, and then this is going to be 8 pi. Right, now let's draw y is equal to negative 1 over 2. So if this point is negative 1 over 2, so if I were to draw the line, so find the points of intersection. So we've got 1 here, 2, 3, 4, 5, 6, 7, 8. So what is the number of solutions? So therefore the total number of solution is what? 8. And that is the exact, or I should say the correct answer. Alright, so we have achieved that because of our understanding of the sin x graph. Now the best way to gain mastery of this particular section is to do more questions. So that's exactly what we are going to do. Let's move on, students. Let's do another question, students. We are given secant 3x is equal to 2 with x being contained in 0, pi. Now we are expected to find the total number of solutions. So what I wish to do is I would like to write this as 1 over cos 3x is equal to 2. Therefore cos 3x is equal to 1 over 2. And the x is lying in the interval 0, pi. Now foremost what I wish to do is I know clearly drawing the graph of cos 3x is going to be an Herculean affair, so I don't want to tread on that. So what I would do is I would like to change the 3x into cos x or cos theta and then move on to obtain the solution. So before I could do that, I would like to extend this interval. So let me write this down. Cos 3x is equal to 1 over 2. Multiplying this by 3, I get 3x element of 0, 3 pi. So the interval is stretched. Next step is I would like to let 3x be equal to theta, and that would give us cos theta is equal to 1 over 2. And 3x is equal to theta. So this is going to be theta element of 0, 3 pi. Now if we were to draw the graph for cos theta, the graph would look something like this. So it starts here, comes down, then moves up, hits here, then moves up and hits down. So let's place the points. So clearly over here it's going to be pi. So this is going to be pi, this is going to be 0, and this is going to be 2 pi, and this is going to be 3 pi, right? And the interval is 0 to 3 pi, so it's enough that we go up until 3 pi. Now if I were to draw the value y is equal to 1 over 2, then the hit, if I were to hit, let me draw the graph, y is equal to 1 over 2, and find out the number of hits from 0 to 3 pi. So that would be, I get a hit here, that's 1, I get a hit here, that's 2, I get a hit here, 3, and this is beyond 3 pi, right? So there are 3 hits, that means there are 3 solutions. So you can write that down. Therefore the total number of solutions for this given question is how much? 3. And that is the solution for this particular question. Students, let's do this question. Students, we've been given to find the number of distinct solutions of the equation 5 over 4 times cos squared 2x positive cos raised to the power of 4x positive sin raised to the power of 4x positive cos raised to the power of 6x positive sin raised to the power of 6x is equal to 2 in the interval 0, 2 pi. This is a lovely question. So foremost, what I wish to do is I would like to consider the given equation. So this is the solution. Consider the given equation. So what is that? That is 5 over 4 cos squared 2x positive cos raised to the power of 4x positive sine raised to the power of 4x. I'm clubbing it as one term. And then cos raised to the power of 6x positive sine raised to the power of 6x is equal to 2. I would like to apply a formula which we have already studied. So if I were to apply that formula, this is cos squared 2x. This is going to be 1 negative 2 times sine squared x cos squared x positive 1 negative 3 times sine squared x times cos squared x is equal to 2. Now I can add 1 and 1 and subtract that 2 there. So that would mean I can cancel these terms and I can rewrite them as 5 over 4 cos squared 2x negative 2 times sine squared x cos squared x negative 3 times sine squared x cos squared x is equal to 0. I can add these two together. That would give me 5 over 4 cos squared 2x negative 5 times sine squared x cos squared x is equal to 0. So that is nice. Next, what I wish to do is I would like to multiply by 4 and divide by 4. So this is going to be 5 over 4 cos squared 2x negative 5 over 4 times 4 times sine squared x cos squared x is equal to 0. I would like to have a 5 over 4. That's why I am just manipulating in this fashion. Now this is rewritten as 5 over 4 cos squared 2x negative 5 over 4. I'm going to write this 4 times sine squared x cos squared x as 2 times sine x cos x raised to the power of 2 is equal to 0. This is rewritten as 5 over 4 cos squared 2x negative 5 over 4. 2 times sine x cos x, that's going to be sine 2x raised to the power of 2 is equal to 0. 5 over 4 is common. I can take it out. So I get cos squared 2x negative sine 2x raised to the power of 2. That's going to be sine squared 2x is equal to 0. So I got cos squared 2x negative sine squared 2x. And I know a formula. What is that? Cos squared x negative sine squared x is equal to cos 2x. But in this case you got cos squared 2x. So I can rewrite this as 5 over 4 of cos 4x is equal to 0, which implies cos 4x is equal to 0. And we given x to be in the interval 0, 2 pi. Now, as I mentioned to you, drawing the graph for cos 4x is not going to be an easy affair. So I would consider it in this fashion. I would like to stretch this interval. So I got cos 4x is equal to 0, and I multiply the x is actually x element, right? So x by 4. So now it's going to be 4x element of 0, 8 pi. So now the interval is stretched. So let me take 4x to be equal to theta. That would mean I now have cos theta is equal to 0, and theta is contained in the interval 0 to 8 pi. Now if I were to draw cos theta's graph 0, so it's going to start here, it's going to come down and move up, come down and move up, come down, move up, come down and move up and come down and move up like that. So let me mention these points, right? So this is going to be 0 and it hits the bottom. This is going to be pi. It raises up, right? So that's going to be 2 pi there, it hits here, is going to be 3 pi, it moves up 4 pi, hits down 5 pi, moves up 6 pi, hits down 7 pi, moves up is 8 pi. So this is the point that we are looking for, right? So if I were to place in the intersection, cos theta is equal to 0. So there is an intersection here, over 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 here, and this is beyond 8 pi, right? So 1, 2, 3, 4, 5, 6, 7, 8. So total number of solutions, therefore total number of solutions in this case is equal to 8. So that is the end of this beautiful question, students. So we will continue again and we will wrap up for tonight, and we will meet again in the next lecture. Thank you. Welcome, students. We have been continuing our study on trigonometric equations. Now we are expected to solve this question. So we got 2 times sin x negative cos x of 1 positive cos x is equal to sin squared x, given the interval being 0, 2 pi. So foremost, what I will do is I will start off by considering the given question. 2 times sin x negative cos x times 1 positive cos x is equal to, I would like to write sin squared x as 1 negative cos squared x. After which I would like to write 1 negative cos squared x as 1 negative cos x multiplied with 1 positive cos x. On the left hand side I've got 2 times sin x negative cos x times 1 positive cos x. So if I were to move everything to the left hand side, I would get 2 times sin x negative cos x times 1 positive cos x negative 1 negative cos x times 1 positive cos x is equal to 0. I would like to take 1 positive cos x as a common factor. That would give me 2 times sin x negative cos x, and that is followed by negative 1 negative cos x times, and that has to be equated to 0. So this is further rewritten as 1 positive cos x times 2 times sin x negative cos x negative 1 positive cos x is equal to 0. Positive cos x negative cos x gets cancelled, giving us 1 positive cos x times 2 times sin x negative 1 is equal to 0. So from here I get 1 positive cos x is equal to 0, and 2 times sin x negative 1 is equal to 0. This is going to be cos x is equal to negative 1. So that would mean x is equal to pi, right? Which is obviously in the given interval, right? So this is one solution. The next solution is going to be 2 times sin x is equal to 1. Sin x is equal to 1 over 2. Now over here we will have to obtain the principal solution. So if I were to take the modulus, then the step 1 would be sin alpha is equal to 1 over 2, step 1. Step 2, find out the quadrant in which the sign value is positive. So if I were to take the representation CAST, all ratios are positive, sign alone is positive. So we want the value of sign to be positive, right? So that is possible only in the first quadrant and in the second quadrant. So the values for the first quadrant and the second quadrant, alpha, and this is pi negative alpha, pi positive alpha, 2 pi negative alpha. So we are looking at this point and this point. So let me write that down. Now clearly in this case alpha is going to be equal to pi over 6 right? Pi divided by 6 is nothing but 30. Sine 30 is 1 over 2. So over here alpha is equal to pi over 6, that's one value. And next we will have to obtain pi negative alpha, which is nothing but pi negative pi over 6, which is 6 pi negative pi over 6, which is 5 pi over 6. So this is the value. So therefore the solution set is going to be, I got the following: pi over 6, pi, and 5 pi over 6. So all of this are in the region 0, 2 pi. So this is the solution for this question. Now you might be wondering, why have I not cancelled one positive cos x with the left and the right? Right? Don't do that. If you're going to be doing it, you would not get this solution, right? This solution would be missed out. Of course, you can come back again and start assigning 1 plus cos x is equal to 0, but most would not go back in achieving this solution. So that's the reason, as a precautionary measure, don't cancel it. Just proceed with the solving the system, and finally you extract the value. Students, let's solve this question. We've been asked to find the solution for this following question. So the question is as follows: find the general solution of the equation 2 sine squared 2x positive 6 sine squared x is equal to 5. So we are expected to obtain the general solution. So whatever solutions are there, we have to get the general solution. So what I would do is I will start off by saying consider 2 times sine squared 2x positive 6 times sine squared x is equal to 5. Now I would like to write this as sine 2x raised to the power of 2 positive 6 times sine squared x is equal to 5. I know that sine 2x is 2 times sine x cos x. That has to be raised to the power of 2. I get 6 times sine squared x is equal to 5. Now I can square them. I would get 4 sine squared x cos squared x positive 6 times sine squared x is equal to 5. Now I would like to use this part of the space. So 2 times 4 is 8, and I have sine squared x cos squared x positive 6 times sine squared x is equal to 5. Now let me rewrite cos squared x as 1 negative sine squared x. So this is 8 times sine squared x of 1 negative sine squared x positive 6 times sine squared x is equal to 5. So this is going to be 8 times sine squared x negative 8 times sine raised to the power of 4x positive 6 times sine squared x is equal to 5. I can add these two and get as 14 times sine squared x negative 8 times sine raised to the power of 4x is equal to 5. So this is what I've got. Now what I can do is I can actually push everything to the right hand side. So that would mean I will now have 5 positive 8 times sine raised to the power of 4x negative 14 sine squared x. So rewriting this, we get 8 times sine raised to the power of 4x negative 14 sine squared x positive 5 is equal to 0. Now I can factorize this as follows: 8 times sine raised to the power of 4x negative 10 sine squared x negative 4 times sine squared x positive 5 is equal to 0. I can take 2 times sine squared x out. That would give me 4 times sine squared x negative 5. 2 times 5 is 10 with a negative sign. That's going to get me 10 sine squared x with a negative sign, followed by, if I were to take 4 out, that would give me sine squared x negative 5. So I cannot take 4 out. If I were to take 4 out, I need to write this as 5 over 4. Then that would give me unwanted issue. So I can take negative 1 out. So if I were to take negative 1 out, this is going to be negative 1 times 4 sine squared x. That's fine. So negative 4 sine squared x is there. I need to get positive 5. So that would mean negative 5 here. So negative 1 times negative 5 would give me positive 5. So that's it. That's fair enough, right? So 4 times sine squared x minus 5, 4 times sine squared x minus 5. So I can take 4 times sine squared x minus 5 as a common factor, giving me 2 times sine squared x negative 1 is equal to 0, right? Now this would mean 4 times sine squared x negative 5 is equal to 0, and 2 times sine squared x negative 1 is equal to 0. From here, 4 times sine squared x is equal to 5, which means sine squared x is equal to 5 divided by 4. 5 over 4. This is greater than 1. So that means no solution. Okay, not possible. The solution cannot exist here because this value 5 divided by 4 is greater than 1. So we have to drop this. So this is dropped. Okay, drop this. So now we have 2 times sine squared x negative 1 is equal to 0. So 2 times sine squared x is equal to 1. So sine squared x is equal to 1 divided by 2. So I can rewrite this as sine squared x is equal to, I need to get 1 over 2, right? So I can write this as sine 45, right? Sine pi over 4, that's giving me 1 over root 2. If I were to square it, I would get 1 over 2, right? So I can rewrite this as sine squared x is equal to sine squared pi over 4. This would mean my alpha is equal to pi over 4. If you remember our previous discussion in obtaining the solution, this is the way we actually explained in the process of extracting alpha. So that would mean the solution is going to be of the form, this means n pi plus or minus alpha. This is the general solution that we have obtained. So this would mean n pi plus or minus alpha is pi divided by 4, where n is an element of integer, right? So that is the solution for this beautiful question. So students, we will move on to the next question. Let's do this question, students. We are expected to find the general solution of the equation 1 negative tan theta times 1 positive sine 2 theta is equal to 1 positive tan theta. So this is what we have been given. So foremost, let us start off by considering the given system, which is 1 negative tan theta times 1 positive sine 2 theta is equal to 1 positive tan theta. Now we know a formula for sine 2 theta, which is 2 times tan theta divided by 1 positive tan squared theta, right? This is multiplied with 1 negative tan theta is equal to 1 positive tan theta. If I were to take the LCM as 1 positive tan squared theta, this would give me 1 positive tan squared theta positive 2 times tan theta times 1 negative tan theta, right, which is equal to 1 positive tan theta. Now this is a perfect square, so I can rewrite this as 1 positive tan theta raised to the power of 2 times 1 negative tan theta divided by 1 positive tan square theta is equal to 1 positive tan theta. Okay, so now we have two components. Now, as I mentioned to you, if you're going to be cancelling these two terms, you have to be a bit careful. What I'm going to do is I'm just going to cross multiply and bring the terms to the left. So this is going to be 1 negative tan theta times 1 positive tan theta raised to the power of 2 is equal to 1 positive tan theta times 1 positive tan square theta. Let me bring these terms to the left, and that would give me 1 negative tan theta times 1 positive tan theta raised to the power of 2 negative 1 positive tan theta times 1 positive tan square theta is equal to 0. Now 1 positive tan theta, 1 positive tan theta can be taken out, and that would in turn give me 1 negative tan theta times 1 positive tan theta. 1 positive tan theta is already taken out, so this is going to be negative of 1 positive tan square theta is equal to 0. So this is further rewritten as 1 positive tan theta times, this is 1 negative tan square theta, negative 1 negative tan square theta is equal to 0. So positive 1, negative 1 can be cancelled, and this in turn is going to be 1 positive tan theta times negative 2 times tan square theta is equal to 0. So this is what I've got. So from here I get 1 positive tan theta is equal to 0. This is going to be negative 2 times tan square theta is equal to 0. Clearly tan square theta is equal to 0. I can rewrite this as tan square theta is equal to tan squared of 0, which would mean alpha is equal to 0, right? Because tan squared 0 is sine squared 0 over cos squared 0, and that's clearly would give me 0. So alpha is equal to 0. So the general solution in this case is going to be theta is n pi plus or minus alpha. So that would mean n pi plus or minus 0, which is nothing but n pi. So n pi is the solution. So let me write that out. Theta is equal to n pi. Okay, so for this part. Now coming back to this part, in this case tan theta is equal to negative 1. Therefore I can write this as tan theta is equal to tan of 3 pi over 4. So clearly in this case theta is going to be n pi plus alpha, which is nothing but 3 pi over 4. So therefore the solution set, therefore the solution is going to be n pi union n pi plus 3 pi divided by 4. This is the complete solution for this question. So it's a lovely question, students. Let's do this question, students. If root of 3 times cos squared x is equal to root of 3 negative 1 times cos x positive 1, the number of solutions of the given equation when x lies in this interval 0, pi over 2 is equal to how many? So in this question we are expected to find the number of solutions for this given equation. So foremost, what I wish to do is consider root of 3 times cos squared x is equal to root of 3 negative 1 times cos x positive 1. Right? So what I would do is I would like to bring all the right hand side terms to the left. So this is root of 3 times cos squared x negative of root of 3 negative 1 times cos x negative 1 is equal to 0. I would rewrite this as root of 3 times cos squared x negative root of 3 times cos x negative negative positive cos x negative 1 is equal to 0. I can take root of 3 times cos x as a common factor for these two quantities. So that would give me cos x negative 1 positive. I can take 1 as a common factor. So that is going to be cos x negative 1 is equal to 0. I can clearly take cos x negative 1 out, and that is going to be root of 3 times cos x positive 1 is equal to 0. So from here we observe that cos x negative 1 is equal to 0, or root of 3 times cos x positive 1 is equal to 0. From here cos x is equal to negative 1 over root 3, and from here cos x is equal to 1. In this case the value of x is equal to 0. Right? Now you might be wondering why I'm not extracting the value of x in this case. So that is for a reason. Now let us just consider the given interval. The given interval is between 0 and pi over 2. So if we were to draw the graph of cos x, the graph is going to be something of this fashion. So at 0 it will hit 1, at pi over 2 it hits 0. This interval alone is required. So between 0 and pi over 2, cos x cannot be negative. So this is not possible, right? So if it is not possible, it means we will have to drop this. So this is dropped. And the only solution in this case is going to be x is equal to 0. But the question wants us the number of solutions for this particular equation. So the answer is, I can state it here, hence the number of solutions is equal to 1. So that is the answer to the question, because the question wants us just to find the number of solutions. And this is a JEE question, mains 2021. So student, having given this solution, let's move on to do the next question. Let's do another question, students. This question has been featured in JEE Mains 2019. So the question is as follows: let S be equal to collection of all theta such that theta is present in the interval negative 2 pi to positive 2 pi, and the given equation is 2 times cos squared theta positive 3 times sine theta is equal to 0. So we are expected to find then the sum of the elements of S is equal to, so this is required. Now we've been given choices. Choice A is 13 pi over 6. choice B is 5 pi over 3, choice C is 2 pi, and choice D is 0. Now, the understanding for this question is we are expected to find all the solutions that are present in this interval, and then we will have to sum up those solutions, and that would give us a value, and we need to take up that value and find where that value occurs among these choices. That is the simplest understanding for this question. So foremost, what I would like to do, I would like to solve this. So consider 2 times cos squared theta positive 3 times sine theta is equal to 0. Now I'm going to rewrite cos squared theta as 1 negative sine squared theta. So this is going to be 2 times of 1 negative sine squared theta positive 3 times sine theta is equal to 0. This is going to be 2 negative 2 times sine squared theta positive 3 times sine theta is equal to 0. I would like to move all these components to the right, so thereby I would get a positive sign for sine squared. So this is going to be 2 times sine squared theta negative 3 times sine theta negative 2 is equal to 0. Now I would like to write negative 3 sine theta as negative 4 sine theta positive sine theta negative 2 is equal to 0. I've got a 2 times sine squared theta. The reason I'm writing it is to facilitate factorization. So if I were to take 2 out, sine theta out, I would get sine theta, 2 times sine theta gives me 2 sine squared theta, and in this case it's going to be 2 there, right? So if I were to take positive 1 out, this is going to be sine theta negative 2 is equal to 0. Clearly I can take sine theta negative 2 as a factor, and I would end up with 2 times sine theta positive 1 is equal to 0. So from here I have 2 times sine theta positive 1 is equal to 0, or sine theta negative 2 is equal to 0. From here sine theta is equal to 2. Sine theta is equal to 2. This is not possible, right? Not possible. So that means we will have to drop this, right? So this is dropped. So now we have 2 times sine theta is equal to negative 1, therefore sine theta is equal to negative 1 over 2. Now we will have to obtain all the principal solutions for this. So step 1, I take the mod of this, so I get sine alpha is equal to 1 over 2, therefore alpha in this case is going to be sine 30 pi over 6. So number 2, I would like to know where sine is negative. So CAST, sine is negative in the 3rd quadrant and in the 4th quadrant, right? In the 3rd quadrant it's going to be pi positive alpha. In the 4th quadrant is going to be 2 pi negative alpha. So the values for this is going to be pi positive pi over 6 and 2 pi negative pi over 6. So this is going to be 7 pi divided by 6. 6 times 2 is 12. This is going to be 11 pi divided by 6. So these are the 2 values that we have got. But apparently we would have to find all values for theta that are present in the interval negative 2 pi comma 2 pi. So if I were to draw the graph, let me just draw the graph and show to you how exactly it looks, right? So when the theta value is 0, sine 0 will hit the origin. So after hitting the origin, it moves up like this and flows like that. Okay, so it comes up like down like this and it moves up. Okay, so and then it goes up and it comes down. Okay, so this is going to be 0, this is going to be pi, this is pi over 2, so this point is going to be 1, and this is going to be 2 pi, this region is going to be 2 pi. So similarly I have a negative 2 pi over here, right, and this is negative pi. So we have to find all points of intersection. So this is 1, if this is negative 1, if this point is negative 1 and this point is say negative 1 over 2, right, sine theta is negative, let me write that down, sine theta is equal to negative 1 over 2. That would mean we are actually looking at the intersection which is moving all the way up unto here, moving all the way up unto here, right? This point is 2 pi, negative 2 pi, and this point is positive 2 pi. So if we were to circle the intersection, this is 1, this is 2, this is 3, this is 4. So these are the points of intersection for the graph, right? The most important question is we would want to know what is this point and what is this point and what is this point and what is this point, right? Because these are the intersecting points and we would have to get these things. So this is at pi, it is sine theta is 0, at 2 pi sine theta is 0, but just before 2 pi there is a value that is actually giving us the intersection, and similarly after pi there is a value that is giving the intersection. So what are those values? Those values are 7 pi over 6 and 11 pi over 6. So this point is 7 pi over 6 and this point is 11 pi over 6. Now we have a corresponding point on the left side of the axis, right, on the other side, the negative side of the axis. So how are we going to obtain? Now 7 pi over 6, now since the graph is symmetric, the point 7 pi over 6 will have this is the intersection for 7 pi over 6, and this would be the corresponding point for 11 pi over 6. But the question is, how are we going to obtain it? It is simple. Since the graph is symmetric, all we need to do is to obtain the corresponding point for 7 pi over 6. I will have to take this 7 pi over 6 and subtract 2 pi. So what do I get? In this case it is 7 pi, 6 times 2 is 12 pi divided by 6, which will give me negative 5 pi over 6. So this point is going to be negative 5 pi over 6. Okay, now I need to actually also obtain the corresponding point for 11 pi over 6. So how do I get that? So let me show you that. This is 11 pi over 6. From 11 pi over 6 I subtract 2 pi, and this is going to be 6, 11 pi, negative 12 pi. 11 pi negative 12 pi is going to be negative pi over 6. So where is that negative pi over 6? That negative pi over 6 is over here. Negative pi over 6. Okay, so the question is, we would have to place all the values of s. So therefore, let me box this. S is equal to, so what are the values we have got? We have got 7 pi over 6, 11 pi over 6, negative pi over 6, negative 5 pi over 6. So if I were to sum up all this, this is going to be 7 added with 11 would give me 18 pi. We have a negative sign. This is going to be 6, negative 5 added with negative pi would give me negative 6 pi. So if I were to take the LCM, this is going to give me 18 pi negative 6 pi, which is equal to 12 pi divided by 6, which is equal to 2 pi. So the sum of the elements of S lands us in choice C. Okay, so this is a lovely question, students. We will move on to the next one. Students, we are going to see the next type of trigonometric equations. So this type is of this form: a times sine x positive b times cos x is equal to c. Now if you get this form, instantly what you need to do, you have to divide by root of a squared positive b squared, and repeat that: a squared positive b squared over here root of a squared positive b squared. Now what is exactly this a over root of a squared positive b squared? So if you were to draw the right angle triangle and taking this as some alpha and this to be a and this to be b, this is going to be root of a squared positive b squared. Now sine alpha is a over root of a squared positive b squared, and cos alpha is equal to b over root of a squared positive b squared, right? So if I were to take this as, say, 1, let me take it as 2. Let 1 be a times sine x positive b times cos x is equal to c. So this is the original form, right? So therefore I can rewrite 2 to be as a over root of a squared positive b squared. That's nothing but sine alpha times sine x positive cos alpha times cos x is equal to c, which I can rewrite as cos x cos alpha positive sine x sine alpha is equal to c, which is nothing but cos of x negative alpha is equal to c. Okay, so this is a very important part. In fact, this is c over root of a squared positive b squared root of a squared positive b squared and root of a squared positive b squared. Okay, so we can't miss that out. So having given you this, let me head on to do related questions of this type. Students, we are being given this question: find the general solution of sine x positive cos x is equal to root of 2. Now foremost, what I would do is I would consider the given question, which is sine x positive cos x is equal to root of 2. Now this is of the form a times sine x positive b times cos x is equal to c, where a is equal to 1, b is equal to 1 and c is equal to root of 2, right? So what did we do? We just took the value of a squared positive b squared and we divided it throughout. So that's going, in this case, is going to be 1 positive 1, which is equal to root of 2. So we will take this value and divide the entire quantity by this root 2. So this is all for your understanding. You don't have to write this as part of the solution. Just keep this at the corner of your mind. So this is going to be 1 times sine x positive 1 time cos x is equal to root of 2. And I would divide this by root 2, divide this by root 2, divide this by root 2. Now clearly root 2 can be cancelled. Now I got 1 over root 2 times sine x positive 1 over root 2 times cos x is equal to 1. I would like to write 1 over root 2 as sine pi over 4 times sine x positive cos pi over 4 times cos x is equal to 1. I can rewrite this as cos x times cos pi over 4 positive sin x times sin pi over 4 is equal to 1. So this is nothing but cos of x negative pi over 4 is equal to 1. I can further rewrite this as cos of x negative pi over 4. It's 1. I can instead replace 1 as cos 0. Now this is of the form cos x is equal to cos alpha. So that would mean x negative pi over 4 is equal to alpha is 0 degrees, right? So the solution, so instead of just going like this, okay, we will have to write the general solution. So therefore the general solution, I don't have to specify this, the general solution is going to be 2n pi plus or minus alpha. This is the general solution for this. So in this case my alpha, okay, so the alpha is 0 degrees here. So on the left hand side we are going to have x negative pi over 4 is equal to 2n pi plus or minus 0 degrees, right? So this can be further rewritten as, let me use this space. So if I were to push this pi over 4 to the other side, I would get x is equal to 2n pi positive pi over 4. So this is the general solution where x is element of z. So this is a good place for us to stop and move on to the next question, because the question wants us to just find the general solution and we have achieved that exactly. Let's do this question, students. We have to find the general solution of root of 3 times cos x positive sin x is equal to 2. So what I wish to do is I would like to take the square of root 3 and the square of 1. 1 is the coefficient of sin x, right? So this is going to give me root of 3 positive 1, which is equal to root of 4, which is going to be equal to 2. So I would have to foremost start off by considering the system. Let me consider root of 3 times cos x positive sin x is equal to 2. Then I would divide by 2, I would divide by 2, I would divide by 2. Clearly this gets cancelled. So I got root of 3 over 2 times cos x positive 1 over 2 times sin x is equal to 1. Now cos 30 is root of 3 over 2 and sin 30 is equal to 1 over 2. I can represent cos 30 as pi over 6. I can represent the same 30 degrees as sin pi over 6. So sin pi over 6 will give me 1 over 2. Cos pi over 6 will give me root 3 over 2. Right? So that's just for your understanding. Now this can be rewritten as cos pi over 6 times cos x positive sin pi over 6 times sin x is equal to 1. This is nothing but cos of x negative pi over 6 is equal to 1. So I've got this. I'm going to rewrite this as cos of x negative pi over 6 is equal to cos 0. Now clearly you can see that this is of the form cos x is equal to cos alpha. So the solution in this case is going to be 2n pi plus or minus alpha, right? Now in this case alpha is equal to 0, right? So therefore this would mean x negative pi over 6 is equal to 2 times n pi plus or minus 0. So from here I can rewrite this as 2n pi positive pi over 6, where the value of n, okay, n is an element of integer. So if I were to box the result, this should be the ideal spot where we can box the result and move on to the next question. Let's do another question, students. This is quite an interesting one. We are expected to find the general solution of the equation sin x positive cos x is equal to 3 over 2. Now foremost, let me consider the given system, which is sin x positive cos x is equal to 3 over 2. Now the coefficient of sin is 1, coefficient of cos is 1. So we would divide throughout by root of 1 squared positive 1 squared, which is nothing but root of 2, right? So this is 1 divided by root 2, 1 divided by root 2, and 1, this would become 3 over 2 times root 2. Okay, now this is nothing but sine of pi over 4, because sine 45 is 1 over root 2, and followed by cos x positive cos pi over 4 times cos x is equal to 3 over 2 times root 2. I can rewrite this as cos x times cos pi over 4 positive sin x times sin pi over 4 is equal to 3 over 2 times root 2. This is nothing but cos of x negative pi over 4 is equal to 3 over 2 times root 2. What is the value of 3 over 2 times root 2? This is actually greater than 1, and we are having a value on the right hand side which is greater than 1, and we are having cos of an angle, and this is not possible. So that would mean, this means no solution exists. So that is a good place for us to stop and move on to the next question. Students, let's proceed to the next question. We are expected to find the number of integral values of k for which the equation 3 times sin x positive 4 times cos x is equal to k positive 1 as a solution, with k being element of real numbers. Right? Now let me just start off by consider the given question. What is it? 3 times sin x positive 4 times cos x is equal to k positive 1. Now this is of the form a times sin x positive b times cos x is equal to c, and so we would divide by root of a squared positive b squared, right? So in this case we would divide by root of 3 squared positive 4 squared root of 3 squared positive 4 squared, and we would divide the entire quantity by root of 3 squared positive 4 squared. So this is what we will do usually, but we are not going to be doing this as of now, right? So this is just for your understanding. Now let me just find out what is root of 3 squared positive 4 squared. This is going to be equal to root of 9 positive 16, which is root of 25, and the values are negative 5 and positive 5, right? So this is how we proceed. So the meaning is the left hand side is defined only for the interval negative 5 and positive 5, right? So what I wish to do is I would now give you the exact solution that matters. So this is just for your understanding. Now, so we have started with considering, okay, so 3 times sin x positive 4 times cos x is equal to k positive 1. Now clearly the left hand side is defined only in the interval negative 5 comma 5. Now why do we say that? Because of the technique that we are adopting to solve the system, right? So this would mean the right hand side will also be defined in the interval negative 5 to 5. So for that to happen, okay, k positive 1 should be lesser than equal to 5 and greater than equal to negative 5. So this is possible only when this occurs, right? So if I were to get rid of this positive 1, then I would have your negative 6 less than equal to k less than equal to 4. So the system will have a solution only when k is lying between this interval negative 6 and negative 4. So this would mean solution exists only when, so k should be negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and then 0, 1, 2, 3, 4. So this is the end of solution for this question. Why do I say this is the end? Because we are only asked to find the number of integral values of k. Now this question was asked in JEE 2021, and this is the solution for this question. So having obtained the solution, students, let us move on. Students, let's do this question. This occurred in JEE Advanced 2018. So the question is as follows: let a comma b comma c be 3 non-zero real numbers such that the equation root of 3 times a cos x positive 2 times b times sin x is equal to c, with x being present in this interval negative pi over 2 comma pi over 2, and as 2 distinct real roots, namely alpha and beta, with alpha positive beta is equal to pi over 3, then we are expected to find the value of b over a, right? So this is a straightforward question. So let's start off by considering the given question. Consider root of a times cos x positive 2 times b of sin x is equal to c. Now, since alpha is a root, if I were to take this as 1, I can rewrite 1 to be as root of a times cos alpha positive 2 times b sin alpha is equal to c. Also given beta is a root. So what happens here? This would mean I can again rewrite 1 to be as root of a cos beta positive 2 times b sin beta is equal to c. Now, this one small correction, it's actually, I've taken it as root of a. In fact, the value is given to be as root of 3. So I would have to make that correction. So this is going to be root of 3 times a positive 2 times b. So that's fine. Similarly, this is going to be root 3 times a and root 3 times a. Alright, so the rest stays as it is. So having made that correction, I would like to eliminate c, so change the sign. So upon changing the sign, c is eliminated. So we would now have root of 3 times a cos alpha negative root of 3 times a cos beta positive 2 times b sin alpha negative 2 times b sin beta is equal to 0. Right. So now what I wish to do is I would like to take root of 3 times a out as a common factor. That would give me cos alpha negative cos beta. I would take 2 times b out. This would give me sin alpha negative sin beta is equal to 0. Now I can apply the much known formula cos c negative cos d. Now if I were to apply this, the formula which we have studied earlier, this is going to be rewritten as negative 2 times root of 3 times a of sine of alpha positive beta divided by 2 times sine of alpha negative beta divided by 2. We have studied this formula in trigonometry, the first series of lectures. So this is what we have got for cos alpha negative cos beta. Now we can also apply a similar formula which we know for sin c negative sin d. So that is going to be 2b times 2 times of cos of alpha plus beta divided by 2 times sine of alpha negative beta divided by 2. So this is what we have got. Now what I wish to do is I would like to take, this is equal to 0, sine of alpha negative beta over 2 and a 2 as a common factor. So I will take 2 out. Along with that, I would like to take sine of alpha negative beta over 2, right? If I were to take this as a common factor, then I would be left with negative root of 3 times a. That's fine. And then followed by positive sign In fact, this has to be followed with sine of alpha positive beta divided by 2, right, for the first term, and a positive sign. 2 is already taken out. I just got a 2b there, and cos of alpha positive beta divided by 2. This is equal to 0, right? So clearly from this particular system, this gets eliminated, right? Because according to the property of algebra, if a dot b is equal to 0, then a is equal to 0 or b is equal to 0, right? We can very well have that there. Hence we now have negative root of 3 times a sine of alpha positive beta divided by 2 positive 2 times b cos of alpha positive beta divided by 2 is equal to 0. Now what is our objective? Our objective is that to find the value of b over a, right? So that is our main focus. Now we are given what we are given. We are given alpha positive beta is equal to pi over 3. So if I were to take this as 2, so therefore 2 can be rewritten as negative root of 3 times a sine of pi over 3, and there is a 2 there, so this is going to be pi over 6 positive 2 times b cos of pi over 3, and there is 2 there, so that's going to be pi over 6 is equal to 0. Now this is nothing but sine 30, right? Now what is sine 30? Sine 30 is 1 over 2, and this is nothing but cos 30. Cos 30 is root of 3 over 2. So if I were to use this, this is going to be negative root of 3 times a 1 over 2 positive 2 times b root of 3 over 2 is equal to 0. I'm going to push everything to the other side. So we are expected to find b divided by a. So let me retain b on this side. 2 times b root of 3 over 2 is equal to root of 3 times a 1 over 2. Now clearly what I can do is I can cancel root 3, and I can cancel a 2 and a 2. So I have 2 times b is equal to a times 1. I need to get b over a, so therefore b divided by a is equal to 1 over 2. So this is a beautiful solution, and you can also rewrite this as 0.5, right? So that's natural, that's trivial. So this is the end of solution for this particular question, students. I hope you got it. So having given this solution, we will move on to do the next question. Students, this is the next type. Probably you can call it as type 3. And over here we will convert the sum to product. So what exactly does that mean? It means if we were to be given a trigonometric equation consisting of sums, then we would somehow ensure that that sum is converted to product form. So having said that, let me just give you an illustration for that. So this is a question, and this question occurred in JEE JEE Mains 2019. Okay. So the question is as follows: if 0 less than equal to x strictly less than pi over 2, then the number of values of x for which sin x negative sin 2x positive sin 3x is equal to 0 is, now we are given the following choices. A is 3, B is 1, C is 4 and D is 2. Right, so you got 3, 1, 4, 2. So we are expected to find the number of values of x for which the equation is satisfied, and that the values of x ought to lie between 0 less than equal to x less than equal to pi over 2. So pi over 2 is open and on the other end 0 is closed. So this is the restrictive condition for the values of x to fall into. So having got that, let us start off with considering the given question. So consider sin x negative, sin 2x positive, sin 3x is equal to 0. Right. Now what I wish to do is I would like to club sin x with sin 3x. That is a very important part of this solution. So clubbing sin x with sin 3x and isolating sin 2x in this fashion, we will be able to simply solve this. Now this is of the form sin c positive sin d, so we can apply the formula. So that's going to be 2 times of sin of x positive 3x divided by 2 times cos is a even function, so it doesn't matter whether you write it as x negative 3x or 3x negative x. So that's it, followed by sin 2x is equal to 0. This is going to be 2 times of sin 4x divided by 2 times cos 2x divided by 2 negative sin 2x is equal to 0. Now I can further rewrite this as 2 times 2 divides 4 2 times, so it's going to be sin 2x, 2 divides 2, so I can rewrite this as cos x negative sin 2x is equal to 0. I can very well take sin 2x out. This is going to give me 2 times cos x negative 1 is equal to 0. From here we get 2 cos x negative 1 is equal to 0 and sin 2x is equal to 0. So this is going to be 2 times cos x is equal to 1. Cos x is equal to 1 over 2. So let us just have cos x, first consider cos x is equal to 1 over 2 so that we can get all the solutions. Now the graph of cos x starts from here and moves up and then it moves in this fashion, right? It goes down and then it rises up. So if we were to study the values of x for which the interval has to be functionally operational, so let me write down the values of x. It's going to be 0 less than equal to x less than pi over 2. So this is what has been given to us. So pi over 2 is right over here because cos pi over 2 hits 0, but it is open. Now let me draw 1 over 2. So 1 over 2 is going to be hitting the cos graph in this fashion. Now it hits here, but it is imperative to understand that we can only take in values which are between 0 and strictly less than pi over 2. So clearly the graph already starts from this point, right? So we are expected to find all x for which this is true. Okay, so we are to find all x lying between 0 and pi over 2 for which cos x is equal to 1 over 2. So clearly there just exists one solution. This implies there is just one value of x in the given, right, in the given interval satisfy, okay, the given equation for the given interval. So that's fine. because we are only expected to find the number of solutions, right? So probably what we can do is we can just underline 1. So now coming to sine 2x, okay, consider sine 2x is equal to 0, and in this case the value of x is contained between 0 and pi over 2. Now what I wish to do is I would like to multiply this by 2. So it's going to be 2x is contained in 0 comma pi. So this is what we've got, and the equation is sine 2x is equal to 0. Now let me just take 2x to be equal to theta. If I were to take that to be equal to theta, then we would have sine theta is equal to 0 and theta being contained between 0 to pi, right? Open. So let me draw the graph. If I were to draw the graph is moving up like this, right? So this is 0 and pi is over here, right? Pi is over here, pi over 2 is over here. So let me just show you. This is how the graph looks, right? So the point is that so if you were to check sine theta being equal to 0, of course this is a graph of sine. Now we cannot hit pi because of the fact that it's an open interval. So the solution is going to be just 1, right? Only this point. So we have just one solution here. We have just one solution here. So the question wants us the total number of solutions. So therefore the total number of solutions are one solution for cos x is equal to 1 over 2 and the other solution sine 2x is equal to 0. So 1 added with 1 will give us 2. So therefore the choice for this question is going to be D. Okay, D is the choice. So having given that solution, we will move on to the next question. Students, let's do another question. This is from JEE May 2021. So the question is as follows: if the sum of the values of x in the interval 0, 2 pi, for which the equation sin x positive, sin 2x positive, sin 3x positive, sin 4x is equal to 0 is, so you have been given the following choices. So A 8 pi, B 11 pi, C 12 pi, D 9 pi. So the understanding of this question is that you're expected to find out all values of x present in this particular interval 0, 2 pi for which this equation is satisfied, and you have to take the sum of those values, and that sum should be featured as one of the right choices in this display, right? So having made the problem clear, let's head on to solve this question. So let us consider the given question. Consider sin x positive, sin 2x positive, sin 3x positive, sin 4x is equal to 0. Now I would like to club sin x with sin 4x. So rewriting, we get sin x with sin 4x, so this is one particular term, followed by sin 2x with sin 3x is equal to 0. Now I would like to apply the formula of sin c positive sin d. So that would give us 2 times, this is x and 4x, so x positive 4x divided by 2 times cos of 4x negative x divided by 2 positive, the same formula I would like to apply. So this is going to be 2 times sine of 2x positive 3x divided by 2 times cos of 3x negative 2x divided by 2 is equal to 0. So this is going to be 2 times of sine x added with 4x would give me 5x divided by 2 times cos of 3x divided by 2 positive 2 times sine of 5x divided by 2 times cos of x over 2 is equal to 0. So this is what we have got. Now I would like to take 2 out. In fact, I can literally cancel them out. So that's exactly what I'm going to do. So 2 can be cancelled, and then I can take sine 5x over 2 out. So let me write that down. Sine 5x over 2 is taken out. That is going to be giving me cos 3x over 2 positive cos x over 2 is equal to 0. Now I would like to apply cos c plus cos d formula. So this is going to be sine of 5x over 2 times, so cos, you need to add these two together, so 3x over 2 added with x over 2, that has to be divided by 2, right? This is one term, followed by the next term. The next term is going to be, you need to have a product sign, so it's a product there. Cos of 3x over 2 negative x over 2 divided by 2 is equal to 0, right? Of course, you need to have the product multiple of 2. I would like to place that 2 over here. So this is rewritten as cos of 4x divided by 2 divided by 2 times cos of 2x divided by 2 divided by 2 is equal to 0. This is going to be 2 times of sine 5x over 2. So this can be further rewritten as 2 divides here 2 times, so, and then I got a 2 here, so that is going to be giving me cos x, and 2 divides 2, I got an x there, so this is going to be cos x over 2 is equal to 0, and then this is going to be 2 times of sine 5x over 2. So this is what we have got now. Now I can drop this 2, and then I can rewrite it as sine 5x over 2 times cos x times cos x over 2 is equal to 0. So this would imply sine 5x over 2 is equal to 0, cos x is equal to 0, and then cos x over 2 is equal to 0. Now when is sine x, or in other words sine 5x over 2 is equal to 0? So to rephrase it, from the graph, say we know the graph of sine x, right? So if we were to draw the graph is in this fashion, a waveform. So clearly when x is equal to pi, sine x will hit 0, and when x is equal to 2 pi, again sine x will hit 0, and so on and so forth. So clearly for all values of x to be equal to n pi, sine x is equal to 0. So this is what we have studied from the graph of sine x. So this would mean for sine 5x over 2 to be equal to 0, 5x over 2 should be equal to n pi, right? So if I were to rewrite this and find the value of x, this is going to be 2 times n pi divided by 5. Now taking the value for n, and n is equal to 1, I need to find all values of x. So when n is equal to 1, I get, so it starts from 0. So if I were to take n is equal to 0, this is going to be 0. Then n is equal to 1, this is going to be 2 pi over 5, n is equal to 2, 4 pi over 5, n is equal to 3, 6 pi over 5, n is equal to 4, 8 pi over 5, n is equal to 5, 10 pi over 5. 10 pi over 5 is nothing but 2 pi. Now it's given that x is actually present between 0 and 2 pi. So that is the reason I have taken n is equal to 0, right? N is equal to 0 is actually producing a value here. Why did I do that? Because this is the interval that has been given, 0 to 2 pi. So we have to stop here. So this would be the all possible values for x for which the equation is true. Now let us move on for cos x. Now cos x is equal to 0 for what values? If you were to draw the graph is something of this fashion, right? This is the graph of cos x. So when exactly cos x becomes equal to 0? Now if we were to take x is equal to pi over 2, cos x will hit 0. That's one value. Now the second value of cos x will be obtained when x is equal to 3 pi over 2, right? So pi over 2 is 0, there is a hit here, and 3 pi over 2, there is again a hit here. Okay, so I'm not moving further. So the next further hit would be 5 pi over 2, but we don't need 5 pi over 2. So let me state that cos x is equal to 0 with x being contained in 0 to 2 pi, and the values of x in this case is going to be pi over 2 comma 3 pi over 2. So this would be the solution, or I should say the values of x for which the equation is holding true. So having got this, so we got two values for x, and we've got a set of values for x over here. And then let's move on to cos x over 2. Now this is cos x over 2. Now the values of x, as I mentioned to you, is between 0 to 2 pi. Now this is x over 2. So in other words, for this to hold good, x over 2 is actually between 0 and pi. Okay, so that is the requirement. Now when exactly this is possible? So when exactly cos of x over 2 is equal to 0? It can be equal to 0 for values of pi over 2, right? I stated already, and 3 pi over 2, and then 5 pi over 2, and so on and so forth. Okay, so on the left hand side, cos x over 2 can only be 0 if x over 2 takes the following values. So let me just consider the first value. X over 2 is equal to pi over 2. 2 gets cancelled, so this implies x is equal to pi, and the value x is equal to pi is perfectly acceptable, right? Because it is actually in the required region, so that's okay. Now when x over 2 is equal to 3 pi over 2, 2 gets cancelled, so this would mean x is equal to 3 pi. So x is equal to 3 pi, this is actually not possible because it goes overboard. Okay, so this one goes overboard. So in other words, this is dropped, this is dropped. So the only values that is accepted is this. X over 2 is equal to pi over 2, because we are able to get the value of x to be in the required interval. So that would mean we only have one solution here, x is equal to pi. Now the question wants us actually to find out the sum of these values, sum of these entries. So that means we need to sum up this, we need to sum up this, and we need to sum up this. So let's do that. So this is going to be 0. There's no point in adding 0 there. So 2 pi over 5 added with, so in fact I can just add 4 pi, 6 pi, 8 pi and 10 pi. So what would that be? This is equal to 2 plus 4 pi, 2 plus 4, 6, 12, 20 and 30. So 30 pi divided by 5 is equal to 6 pi. And in this case is going to be pi positive 3 pi. It's 4 pi divided by 2, which is equal to 2 pi. So that's fine. 2 pi, that's one value. So this is pi, another value. So totally in all we got 6 pi added with 2 pi added with pi, which is equal to 9 pi, which is the solution for this question. So I have given you some list of choices. So let's go back and check those choices. So clearly you can see that is a choice. So this would be the solution for this question. So we got a list of choices: 8 pi, 11 pi, 12 pi, but apparently D is the only one which got 9 pi. So that is the solution. So that is the end of this particular question, students, and we will move on to the next question. Let's do another question, students. This question occurred in JEE Advanced 2011. Okay, 2011. So the question is as follows. Let me state it. It says the positive integer value of n greater than or equal to 3 satisfying the equation (1 over sine of pi over n) is equal to 1 over sine of 2 pi over n plus 1 over sine of 3 pi over n is. So we are expected to find that value of n which satisfies this given system. So foremost, what I wish to do is let us start off the solution. Consider the given 1 over sine pi over n is equal to 1 over sine 2 pi over n positive 1 over sine 3 pi over n. I would like to move this quantity to the left. So that's going to be 1 over sine pi over n negative 1 over sine 3 pi over n is equal to 1 over sine 2 pi over n. I would like to take the LCM. That's going to be sine pi over n times sine 3 pi over n. This is going to be sine 3 pi over n negative sine pi over n is equal to 1 over sine 2 pi over n. Now this is sine c negative sine d. So that is going to be 2 times of cos of 3 pi over n added with pi over n, right? And that has to be divided by 2 times sine of 3 pi over n minus pi over n divided by 2. So we have converted this quantity into product form, and this has to be divided with sine pi over n times sine 3 pi over n is equal to 1 over, now this is sine 2 theta, so that's going to be 2 times sine theta times cos theta, right? Now sine pi over n, sine pi over n can be cancelled. Now let us simplify this one. So this is going to be 2 times cos of 3 pi added with pi gives me 4 pi divided by n, but that has to be divided by 2. So that's going to be 2 pi over n times sine of 3 pi negative pi is 2 pi, that has to be divided by 2. So that will give me pi over n. So that's fine. This is divided by sine 3 pi over n is equal to 1 over cos pi over n. Now what we can do is we can cross multiply this to the left and this to the right. So that would give me cos 2 pi over n times, now I would like to rewrite this as 2 times, I will push the 2 inside, so it's going to be 2 times sine pi over n multiplied with cos pi over n. So this is 2 times sine theta cos theta, which is equal to sine 3 pi over n. So this can be clubbed together and written as sine 2 theta. So sine 2 pi over n, and you got cos 2 pi over n, and you got sine 3 pi over n. So I have to take into account this 2. Apparently I have not placed this 2, so that 2 would be followed here. So when I cross multiply, this is going to be 2 squared, so one of the 2 can be written within the parenthesis, and thereby I would get sine 2 pi over n, and followed by the 2 here. Now what I can do is this can be rewritten as 2 times of sine 2 pi over n times cos 2 pi over n is equal to sine 3 pi over n. Now this is 2 sine theta cos theta, so that's going to be sine 2 of 2 pi over n is equal to sine 3 pi over n. So this is nothing but sine 4 pi over n is equal to sine 3 pi over n. Now the question comes is, when will this be equal, or when will this equation be true? Now clearly, without any doubt, this will only be true when n is equal to 7. Now I'm going to show you here how n is equal to 7. Now we got sine of 4 pi over n, right? Now I can rewrite this as sine of pi negative, say 3 pi over 7, right? Because 7 pi negative 3 pi over 7 would give me the required value. So this is actually 4 pi over n, right? So I'm taking n to be equal to 7. So if I take n is equal to 7, this is going to be sine 4 pi over 7. I'm writing sine 4 pi over 7 as sine of pi negative 3 pi over 7. Right? Now we know that sine of pi negative theta is equal to sine theta. So in this case it's going to be sine 3 pi over 7. Now check the quadrant. Now this is pi negative, right? So it means this is in the second quadrant, but sine is positive, so that's why I get plus there. So clearly you can see that sine of 4 pi over n becomes equal to 3 pi over 7 when n takes the value 7, right? So that is the solution for this question. I hope you got the glimpse of it. And having obtained this, students, we will head on to solve the next question. Welcome students. In this class we will be learning the fourth type. In fourth type we will have to adopt this approach, product to sum. So if we have a trigonometric equation which is in product form, we will have to convert it into sum form. So this is the question. So find the number of solutions for the trigonometric equation. So this is the equation that is given. Sine 3 theta equals 4 times sine theta times sine 2 theta times sine 4 theta, with theta being given to be contained in the interval 0, pi, closed interval, right? So let us start off with writing this question. Consider sine 3 theta is equal to 4 times sine theta times sine 2 theta times sine 4 theta. I would like to write sine 2 theta as sine of 3 theta negative theta, and I would like to write 4 theta as sine of 3 theta positive theta. Now we know a very important formula, which is sine of a negative b times sine of a positive b is equal to sine squared a negative sine squared b. So using this formula, I can rewrite this as 4 times sine theta of, in place of a I've got 3 theta, so this is sine squared 3 theta. In place of b I've got sine theta, this is sine squared theta, right? On the left hand side I have sine 3 theta. Now sine 3 theta as a formula, what is that? That's nothing but 3 times sine theta negative 4 times sine cube theta. If I were to distribute the quantities on the right hand side, this is going to be 4 times sine theta times sine squared 3 theta negative 4 times, this is sine theta and sine squared theta, so this is going to be sine cube theta. Now clearly what we can do is we can actually cancel negative 4 times sine cube theta with the negative 4 times sine cube theta, which are occurring on the either ends of the equal to sign. So that's gone. So now we got 3 times sine theta is equal to 4 times sine theta times sine squared 3 theta. Now one word of suggestion is that you can very well cancel the sine theta, so like this, but when you cancel them, make sure to place sine theta is equal to 0 on the other end, because this is also a solution. So having mentioned that, I am getting 3 is equal to 4 times sine squared 3 theta. I would like to write it like this: 4 times sine squared 3 theta is equal to 3, and then sine squared 3 theta is equal to 3 over 4. So that means sine 3 theta is equal to root 3 over 2. Of course there is a plus and a minus. Okay, so we would be producing a set of solutions for this. We would be producing a set of solutions for this. Now the theta value is present in 0, pi. Now if you were to draw the curve, the sine curve, see the sine curve is heading like this, right? Now this is pi over 2 and this is pi. This is 0 and this is pi. So how many solutions do we get here? We have 1 over here, we have 1 over here. So the total solutions is equal to 2 for this, right? So let's move on to see this. So we have here sine 3 theta is equal to root of 3 over 2 with a plus and minus. Now clearly theta is contained in 0, pi. Now there is a 3 theta. I would like to get rid of this, so I multiply this by 3. So this is going to be 3 theta, element of 0, 3 pi, and let me write this down. So 3 theta is equal to plus or minus root of 3 over 2. Now let me take 3 theta to be equal to some x. So this would mean I now have sine x is equal to plus or minus root of 3 over 2, with x being element of 0, 3 pi. So if I were to draw the graph is going to be, so this is 0, pi, 2 pi and 3 pi, right? This is what we are talking about. So root 3 over 2 positive side, this would be hitting from this side, and the root 3 over 2 from the negative side would be hitting up into here, right? Because this is 3 pi. So if I were to round them up, the intersecting points, I would get a point here, 1, 2, 3, 4, and this is also an intersecting point, right? 1, 2, 3, 4, 5, 6. So totally 6 in the previous case solutions. So number of solutions. In this case it is 6. In the previous case we had 2, right? So it's going to be 6 positive 2, which is equal to 8. So this is the solution. The total number of solutions is 8, and that is a good place for us to stop. This is a very interesting question. Let me write that question down. Find the number of solutions for the equation tan of 5 pi times cos alpha is equal to cot of 5 pi sin alpha, right? Such that alpha is in the interval 0, 2 pi. Now foremost, what I would like to do is I would like to convert the right hand side cot into tan. So we know that cot theta is equal to tan of pi over 2 negative theta. So using this formula, I can now have tan of, this is in place of theta, I've got this, right? 5 pi cos alpha is equal to, in place of cot, I would like to write tan of, so this is my theta, so this is going to be pi over 2 negative of 5 pi times sin alpha, right? Fair enough. Now this is nothing but, this is the general solution, right? This is the general solution form that we saw. So what was the general solution form we saw for tan? Tan x is equal to tan alpha, right? And such that the values of x is given to be as n pi positive alpha. I'm onto a new page, so let me rewrite the last step. So we have here tan of 5 pi times cos alpha, and this is equal to tan of pi over 2 negative 5 pi times sin alpha. Now this is of the form, this is of the form, the general solution for tan x is equal to tan alpha, where x is equal to n pi plus alpha, right? So this would mean 5 pi times cos alpha is equal to n pi positive, this entire component, what is that? Pi over 2 negative 5 pi times sin alpha. This is my alpha, this is my x. So we have to equate. In other words, instead of saying equate, the best term is we have to write it in this form. So I have written it. Now what I wish to do is I would like to actually take the LCM as 2. So if I were to do that, this would give me 2n pi positive pi divided by 2. Now I have a negative 5 pi times sin alpha. So move that to the left hand side. So it's going to be 5 pi times cos alpha positive 5 pi times sin alpha. Now if I were to take 5 pi out, this would give me cos alpha positive sin alpha. Now from here I can very well take pi out. So if I were to take pi out, this is going to be 2 times n positive 1 divided by 2. So the pi and the pi can be cancelled. So we will now have 5 there of cos alpha positive sin alpha is equal to 2 times n positive 1 divided by 2. I can move this 5 down, so that is going to be cos alpha positive sin alpha is equal to 2n positive 1 divided by 5 times 2 is 10. So in this case n is an element of z, right? So having obtained this far, what is the understanding that we get from here? So the understanding is that we need to find all n such that the left hand side is equal to right hand side, right? That is the first step. Now after we have found the collection of all n's, we will have to go and find, after this we need to find all alpha for which the equation is true, right? The equation gets satisfied. So that is the understanding. Now why am I talking about all alpha? Because that is what the question wants. The question wants to find the set of all solutions that are satisfying the given system, right? So that is the reason I'm looking for alpha. Now before I could head on to alpha, I need to exactly find out the existing range of n for which the left side is equal to right hand side. That is important because in this case you can clearly see that n is an element of z, set of all integers. So that is an infinite set, but we do not want that infinite set, right? We want the specific range for which the system is true. So to get that specific range for the system to be true, let me just draw your attention to the certain system. Say for example, we know that we were dealing with a times cos alpha positive b times sine alpha. Now when we wanted to look at the range of this particular equation, we found that this expression is valid for negative root of a squared positive b squared less than equal to a times. In fact, instead of saying alpha, I can take it as x, right? So this is going to be less than equal to a times cos x positive b times sin x less than equal to root of a squared positive b squared. So this is the validity for which the given system will be true. And we actually did a lot of detailed study with regard to this. Now what have we got here? We have got cos alpha positive sine alpha is equal to 2n positive 1 divided by 10. Now this one will exist. Say for example, now clearly we can see the coefficient of cos alpha is 1 and coefficient of sine alpha is 1. Now this would be existing for values of negative root of 1 squared positive 1 squared less than equal to cos alpha positive sine alpha less than equal to root of 1 squared positive 1 squared. So that would mean we have a negative root 2 less than equal to cos alpha positive sine alpha less than equal to root 2. So this is the range for which cos alpha positive sine alpha will be true. Now similarly, this value 2n positive 1 divided by 10 will have to be present in this particular range, negative root 2 less than equal to positive root 2. Now if I were to take the value of root 2, it's approximately 1.4. So it's a 1.414, but I'm just taking the approximate value of 1.4 with a negative sign less than equal to 2n positive 1 divided by 10 less than equal to 1.4. If I were to multiply by 10, I get negative 14 less than equal to 2n positive 1 less than equal to 14. Move the ones to the other side, this would give me negative 13 less than equal to 2n less than equal to positive 13. So this is what I have got here. So this is going to be negative 15 less than equal to 2n less than equal to 13, right? Because when we move the negative positive one to the other side, it will become negative 1. So this is going to be negative 15. So dividing by 2 throughout, this would give me negative 7.5 less than equal to n less than equal to, dividing by 2, this is going to be 6.5. So the value for which the given system will be true in the case of n is, this is the interval negative 7.5 less than equal to n less than equal to 6.5. So if we were to write down the values of n, the list of values that n would take, they are as follows, right? So what we can do is we can start writing that value. Now since n is an element of integer, I'm taking only integer value. So this start from -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5 and 6. So this is for n, but we are not looking for n. Now if you were to count the number of values, you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values. The total values for n is 14. Now we are interested in finding the number of values for alpha, right? Now for every value of n, there would exist two values of alpha. Now how am I saying that? Now we have this system, right? Let me show you this. So we got this. Sin alpha plus cos alpha is equal to 2 times n positive 1 divided by 10. Now let me take n to be equal to 0. If n is equal to 0, I would get sin alpha positive cos alpha is equal to 1 over 10. Now we know that this is possible, okay, if the range is sin alpha positive cos alpha lies between -√2 and +√2. So that would mean I would have to have a product multiple. We have already done questions with regard to this pattern, right? So how to find the required alpha. So what I will do is I will multiply this by 1 over √2 and this by 1 over √2. So clearly this is going to be sine of pi over 4 times sine alpha positive cos of pi over 4 cos alpha is equal to, this also has to be multiplied. So this is going to be 1 over 10 times √2. So if I were to write this, this is going to be cos of alpha negative pi over 4 is equal to 1 over 10 times √2. Now for this, there would be two values, okay? Two values will exist, which we have already seen, right? That is the reason that I have mentioned here, that for every value of n, there would exist two values of alpha. So therefore, if we were to answer the question, therefore the number of values of alpha for which the equation is true is what? Is 28. Why is it 28? Because I have already obtained the value for n, which is 14. So 14 times 2 will give me 28. This is a good problem, students. I hope you understood this, and we will move on to the next type. Students, we are heading on to type 5 of trigonometric equations. So now in this type, you will be encountering a trigonometric equation of this fashion. So it will be sin x plus or minus cos x along with sin x times cos x. And since it's an equation, it will be equated to 0. Now to handle questions of this fashion, we would like, or in other words, we would approach this by making the following substitution. We would state sin x positive cos x to be equal to some t. Now just by having this substitution, we can target both sin x positive cos x as well as sin x times cos x. Now raise this to the power of 2. This is going to give me sin squared x positive cos squared x positive 2 times sin x cos x is equal to t squared. This is going to be 1. I can move the 1 to the other side. So that would mean I now have 2 times cos x sin x, or sin x cos x is equal to t squared negative 1. From here I get sin x cos x is equal to t squared negative 1 divided by 2. So this is a brilliant substitution, and we will also see questions related to this. Now alternatively, or I should say the second form that would be emanating from this type would be forms of this fashion. say sine raised to the power of 4 of 2x positive cos raised to the power of 4 of 2x is equal to sine times 2x, or sine 2x times cos 2x. So in this case, if you are encountering something of this nature, then what you will have to do is you will have to introduce a new variable. Okay, introduce a new variable. And what I'm going to do is I'm going to give you an example so that you can have a better understanding of this particular type. So let's do that. So this is the question we've been given. Find the general values of x satisfying the equation. So the equation is sine raised to the power of 4 2x positive cos raised to the power of 4 2x is equal to sine 2x times cos 2x. So we are expected to find all values, or I should say the general values of x that satisfies this given equation. So let us start off by consider sine raised to the power of 4 2x positive cos raised to the power of 4 2x is equal to sine 2x times cos 2x. Now this as a formula which we have seen in the earlier classes. So I'm going to write this as 1 negative 2 times sine squared 2x times cos squared 2x is equal to sine, this is 2, right? Sine 2x times cos 2x. Now let me take sine 2x times cos 2x is equal to t. So that would mean I now have 1 negative 2 t squared is equal to t. I can move these to the right, so that would give me 2 times t squared positive t negative 1 is equal to 0. Now I can further rewrite this as 2 times t squared positive 2t negative 1 is equal to 0. From here I take 2 and a t out, I get t positive 1. I take a negative 1 out, I get t positive 1, right, is equal to 0. So from here t positive 1 times 2t negative 1 is equal to 0. So this would mean I get t is equal to negative 1 and 2t is equal to 1, which implies t is equal to 1 over 2. So two values are there, right? So let me take this value first. Okay, let t be equal to negative 1 be first considered. Now since t is equal to sine 2x times cos 2x, this would mean I now have sine 2x times cos 2x is equal to negative 1. I want to multiply both sides by 2. So this would give me negative 2, and this is 2 times sine theta cos theta. That is nothing but sine times 2 of theta, right? Sine 2 theta. But what is this? Let me write that down. What is this? This is nothing but sine 4x is equal to negative 2. This is not possible. In other words, you can say no solution or solution doesn't exist. No solution is possible, right? For the very fact that you are getting sine 4x being equal to negative 2. So we will have to drop this. So now moving on, we need to take t being equal to 1 over 2. So this would mean I now have sine 2x times cos 2x is equal to 1 over 2. I'm multiplying 2 by both sides. So this is going to give me sine times 4x is equal to 1. Now the question comes is, when would this be possible, right? When exactly I can have this to be a reality? This is achievable. Now let me draw the graph of sine x. Now sine x graph is like this. Okay, it goes on like that. Now we are interested in the situation when sine x hits 1. This is the 1 here, right? When sine x is hitting 1, we are interested in these points, this point, and this point, and so on. Okay, because of the fact that we are keen in getting this, because that is the solution. So that point would give us the solution. Now, when is this possible? This happens at pi over 2, right? And this happens at 5 pi over 2. This would be 9 pi over 2. So in general, if I were to look for all values of x for which sin x hits the value 1, then that is nothing but 4n positive 1 times pi over 2. This is a standard value, so you will have to remember that. Okay, sin x will be equal to 1 when x takes the values 4n positive 1 times pi over 2. So this would mean this is possible only when 4x is equal to 4n positive 1 times pi over 2. So that would mean x is equal to 4 times n positive 1 times pi divided by 8. Right, so this is the required x that we are looking for, and it's a good place for us to block this. So that is the requirement. So we are asked to find the general value of x. The key is general value of x that satisfies this equation. So this is the general value of x that satisfies this equation. So I mentioned this. We'll move on to the next question, students. Let's do this question, students. We are given to solve this equation. Solve the equation. 4 times cot 2 theta is equal to cot squared theta negative tan squared theta. Right, so we have this. Now what I wish to do is, let me just start off with considering the given system. Consider 4 times cot 2 theta is equal to cot squared theta negative tan squared theta. I would like to convert everything into tan. So I can rewrite cot 2 theta as 4 over tan 2 theta is equal to, I can write cot squared theta as 1 over tan squared theta followed by negative tan squared theta. If you were to take the LCM, this is going to be tan squared theta and 1 negative tan raised to the power of 4 theta. So this is what I've got. Now on the right hand, on the left hand side, I got 4 over tan 2 theta. Tan 2 theta has a formula 2 times tan theta divided by 1 negative tan squared theta, right? So I can flip this. I would like to use this part of space. If I were to flip it, I will get 4 times of 1 negative tan squared theta divided by 2 times tan theta, and this is going to be 1 negative tan raised to the power of 4 theta divided by tan squared theta. Right? Fair enough. So I can get rid of this tan theta with this tan theta. Thereby I would now have 4 times of 1 negative tan squared theta divided by 2 is equal to 1 negative tan raised to the power of 4 theta divided by tan theta. Now what I can do now is I can rewrite 1 negative tan raised to the power of 4 theta in this fashion. So let me just continue here. So this is going to be 4 times of 1 negative tan square theta is equal to, of course there is 2 there, so this is going to be 1 negative tan square theta times 1 positive tan square theta divided by tan theta. Now you can clearly see 1 negative tan square theta and 1 negative tan square theta. Of course you will be tempted to cancel it, but you can cancel it, but upon cancelling it you should also consider the solution. So this would mean, let me show that, this would mean 1 negative tan square theta is equal to 0, and that would mean tan square theta is equal to 1. So this solution should be found. You can cancel it, but make sure to equate it to 0 and extract the value for tan square theta is equal to whatever that you are cancelling. In this case, it's tan square theta is equal to 1. So having mentioned that, you have 2 here. This 2 can divide 4. So I got a 2 there. And if I were to cross multiply this part, this is going to be 2 times tan theta is equal to 1 positive tan square theta. Now I can move this to the other end. So that would mean I have tan square theta negative 2 times tan theta and positive 1 is equal to 0. This is a perfect square, so I can write this as tan theta negative 1 raised to the power of 2 is equal to 0, which means tan theta negative 1 is equal to 0, which means tan theta is equal to 1. Now you have tan theta is equal to 1 and you got tan square theta is equal to 1. Now this is a bigger set than this. So meaning if you can find the solution for this, it would mean that the solution of this would be contained in this particular set. That is the understanding, right? Because this is a larger set than this. Now having studied general solution, let me use this space and complete this question off. Now I would like to consider this. So we have tan square theta is equal to 1, which means tan square theta is equal to tan, so I can clearly write 1 as 1 squared, right? So this is going to be tan pi over 4, I can take it as squared, right? So because tan 45 is nothing but 1. So this would mean the values for which it is satisfied is going to be n pi plus or minus alpha, right? This would be the general solution, right? In this case, it's going to be theta. So rewriting, I can state this: the general solution for this particular equation. So theta would be equal to n pi plus or minus pi divided by 4. That is the value that we are looking for, and that is the solution's completion. Students, we are heading out to learn type 6. Now in this type 6 we will be using the range of the function. Now there are some standard concepts you will have to know. In other words, you will have to know the ranges of the following trigonometric functions. So foremost, sin x. Now sin x will lie between -1 and +1, followed by cos x. Cos x will lie between -1 and +1. Now coming to tan. Now tan x is for all values of x. So in this case, if someone were to ask you the range of tan x, so this is going to be true for all x element of real numbers. And fourth one, cot x will also be true for all values of x element of real numbers. Now number 5, you have cosecant x. Cosecant x will be valid if the modulus of cosecant x is greater than or equal to 1. Now sixth one, for secant x, the mod of secant x should be greater than or equal to 1. So this is the standard range of trigonometric functions which would be used in solving questions in this type. Let's do this question, students, that we can further understand the concept of type 6 where we are employing the range of the function. So the question is as follows. We are expected to solve for x such that we got cos x positive cos 2x positive cos 3x is equal to 3. Now foremost, if you were to consider the given system on the left hand side, it is imperative for us to understand that the maximum value of cos x has to be attained here, followed by the maximum value, which is 1, and the maximum value for cos 3x should also be achieved here. Only then we can have left hand side to be equal to right hand side. So this is the requirement So having made that statement of thought, let me just take that value. Cos x should be equal to 1 here, and cos 2x should be equal to 1 here, and cos 3x should be equal to 1 here. Now the question comes is, when is this possible? When cos x becomes equal to 1? If you were to see the graph of cos x actually goes up like this, right? This is the graph. Now clearly when x is equal to 0, cos 0 hits the value 1. And if you were to continue this, you can clearly see that the next one will be hit when x is equal to 2 pi, and it will continue in this fashion. So the first hit is at 0, the second hit is at 2 pi, and the next hit will be at 4 pi. So if it were to turn up and move, this point is going to be 4 pi. So in general, cos x can be hitting the point 1 for all values of x in this fashion, 2n pi. So this is the requirement. So similarly, cos 2x will be equal to 1 when 2x is equal to 2n pi. That would mean x is equal to n pi here, and so on and so forth. In this case, 3x should be equal to 2n pi. So that means x is equal to 2n pi divided by 3. So you got 3 sets, but you don't have to write it like this to represent the general solution. Say for example, you don't have to say the set of all x's that are required to satisfy the system is 2n times pi union n pi union 2n pi over 3. You need not have to say that. Now why? You will understand why. Right? So this is not the accepted way to represent the general solution. So what is the accepted way? Because you have to understand that if there are sets like this, say for example you have the largest set, say set A, and you got the next set B and next set C. There's no point in writing it as A union B union C, because B and C are already present in A. It is sufficient enough to write the final set A, because A has B and C both in it. So that is the idea that we have to implement in this case. Because for example, if I were to take n is equal to 0 over here, I would get the first value as 0. N is equal to 1, 2 pi, and then 4 pi, and then 6 pi, and so on and so forth. So this is for the first set. Now if I were to take n is equal to 1, say n is equal to 0, I get 0 here, that's fine. So these are all indicative of values for x, right? And n is equal to 1, I get pi. N is equal to 2, I get 2 pi. N is equal to 3, I get 3 pi, and then 4 pi, and then 5 pi, and then 6 pi, and so on and so forth. A careful observation will reveal to you that 0 is present here, 2 pi is present here, 4 pi is present here, 6 pi is present here, and so on and so forth. In other words, what I wish to bring to your attention is that x is equal to 2 times n times pi is already contained in x is equal to n pi. So there is no point in representing this, so we can drop this. So we only have this and we only have this. Now these two sets are independent. In other words, you wouldn't be able to contain one into another. That wouldn't be possible, because for the simple fact, now if I were to write in all values of x, say n is equal to 0, I do get 0 here. N is equal to 1, I get 2 pi over 3. N is equal to 2, 4 pi over 3. N is equal to 3, 6 pi, that's 2 pi, and then so on and so forth. So clearly you can see that I will definitely get 0, I will definitely get 2 pi, but I would not be able to get pi, right? So therefore the general solution is going to be the union of n pi with the union of 2n pi over 3. So that is the solution for this question, and we have just done that using the concept of range. So we will move on to do the next question. Let's do this question, students. This is an interesting question. We are expected to solve for x, given that sine cubed x negative cos cubed x is equal to 1 positive sine x times cos x. Now I would like to use a cubed negative b cubed formula, which is, we all know that it's a negative b times a squared positive b squared positive ab. So using this formula, I can rewrite the left hand side in this following fashion. So hence sine cubed x negative cos cubed x is equal to 1 positive sine x cos x now becomes, so this is equal to sine x minus cos x times sine squared x positive cos squared x positive sine x cos x is equal to 1 positive sine x cos x. So this is going to give us 1, so it's going to be 1 positive sine x cos x, and this is going to be sine x negative cos x, which is equal to 1 positive sine x times cos x, right? So 1 positive sine x times cos x and 1 positive sine x times cos x can be cancelled, but you will have to equate them to equal to 0. Have that in mind. So from here I would get sine x negative cos x is equal to 1. Now let me just focus my attention onto this. So from here I get sine x cos x is equal to negative 1. I multiply by 2 both sides. This is going to give me sine 2x is equal to negative 2, and this is not possible. So as I mentioned to you, this will not yield a solution, so we have to drop this. So hence, coming to this, so we will have to employ the previous technique, that is multiplying by the square of the coefficient. So you got 1 over here, 1 over here, so we will have to multiply by root of 1 squared positive 1 squared, which is nothing but root of 2, right? So we will have to the only thing is that we will have to multiply it in the denominator. So that means the coefficient divided by root 2 times sine x. So this is how we do that, and followed by, this is a negative sign here, right? So negative 1 over root of 2 times cos x is equal to 1 over root of 2. So this is how we multiply. Now what I wish to do is I would like to multiply both sides by negative 1. So if I were to do that, this is going to be rewritten as 1 over root 2 times cos x negative 1 over root 2 times sine x is equal to negative 1 over root 2. Now this is going to be cos pi over 4 times cos x negative sine pi over 4 times sine x is equal to negative 1 over root 2. Clearly write this as cos of x positive pi over 4, and on this end I will have to place negative 1 over root 2. Now let me just bring your attention to this fact. Now cos of pi over 4 gives us 1 over root 2, but the point here is we will have to bring negative 1 over root 2, right? Now we have already studied this formula. Cos of pi positive theta will give us cos theta, right, depending upon the sign. If it is plus, we would get a plus, we would get a minus if it is a minus, depending upon what we are looking for. Now if it is going to be negative, I would like to, right, let me just place plus or minus there. Now I would like to get pi over 4 here. So if I were to place pi cos of pi, so instead of going plus, I can also move towards the negative side. So place this as pi over 4. Then if you were to go to the quadrant CAST, 180 degrees here, cos is negative on this end, right? Now in this case it would be k pi, right? So cos of k pi plus theta would give us plus or minus cos theta. Now I would like to actually get negative 1 over root 2. So for that I'm going to go to the second quadrant because pi negative theta. So let me just show you this. So this is going to be cos of pi negative theta, and that would produce me negative cos theta because of the fact that over the second quadrant only sign is positive. So I would like to rewrite using this cos of pi negative theta. I would like to represent 1 over root 2 with a negative sign. So that in that case, I know that cos pi over 4 is 1 over root 2. So I will place pi over 4 here. So if I were to place pi over 4 here, this is going to give me negative cos pi over 4, which is subsequently going to be negative 1 over root 2. So this right hand side is written as negative, right? In fact, I don't have to place a negative sign. I need to just represent the value negative 1 over root 2 by cos of pi negative pi over 4. So it's going to be cos of pi negative pi over 4 on the right side. On the left side there's nothing but cos of x positive pi over 4. Now this is similar to cos x is equal to cos alpha, where the solution is going to be 2n pi plus or minus alpha, right? We have already studied this. So this implies x positive pi over 4 is equal to 2n pi. My alpha in this case can be calculated. So it's going to be cos of 3 pi divided by 4. So this is going to be my alpha, 3 pi divided by 4. So if I were to move pi over 4 to the other side, I would get x is equal to 2n pi positive, it's actually plus or minus, right? Plus or minus 3 pi divided by 4. And when pi over 4 moves up, it becomes a negative pi over 4. So this is the general solution, students, for the question that we had been given. So that completes the solution, and we will move on, students, to the next type. Let's do this question, students. This question occurred in JEE Mains 2019. So we are expected to find all the pairs of x comma y that satisfies the following inequality, which is 2 times square root of sine squared x negative 2 times sine x positive 5 times 1 over 4 times sine squared y less than equal to 1. Right? So we have been given the following choices, but there is this following condition that is being attached, and that condition is also satisfy the equation. So the choices are 1, 2 times modulus of sine x is equal to 3 times sine y, 2 times sine x is equal to sine y, 3 sine x is equal to 2 times sine y, and 4 sine x is equal to modulus of sine y. So let me reiterate the question. The question wants us to find all pairs of x comma y which is given to be satisfying this inequality, but they also satisfy one of the equations that have been stated here. So that is the catch. So the clue that we have been given here is the x and y that we are going to be obtaining satisfies this equation. Right, now simultaneously we will have to locate that equation which is also satisfied by the same pair x and y, and it is present as one of the correct choices in this list. So let us rewrite the given question. So as usual, I'll start off by saying consider 2 times square root of sine squared x negative 2 times sine x. I would like to write 5 as 1 positive 4 times 1 over 4 times sine squared y less than equal to 1. I can very well cancel the 2 here with the 4. So that would give me a 2 there. Since this is a perfect square, I can cross multiply, and that would give me sine squared x negative 2 times sine x positive 1. I'm clubbing this as one term, and then 4 less than equal to 2 times sine squared y. Now this is actually a perfect square, right? I can write this as sine x negative 1 raised to the power of 2. When I expand this, I would get sine squared x negative 2 times sine x positive 1 positive 4 less than equal to 2 times sine squared y. So this is what I have got. Now we will have to find out the values of x and y for which the inequality holds good. Now to achieve that, we will have to first locate the minimum value and the maximum value. In other words, we are trying to locate the interval. So for that, foremost what we have to do is to find out when exactly this quantity would become minimum. Similarly, we would have to obtain the interval and for the left hand side expression, and in that interval we would have to have the minimum value and the maximum value. So it's all interval based. If we can obtain that interval, that would help us in achieving the required x and y and subsequently answer the question. So clearly the minimum value that sine squared y can take is going to be 0. So just place that. Subsequently, we would have to find out the maximum value that sine squared y can take. That is going to be 1. But since there is a scalar multiple of 2, we would have to multiply that maximum value with 2. So that would mean we would have 0, 2 as the range here. Now I would not place the inequality sign as yet. I would go up over here to find out the minimum value and the maximum value. Now clearly the minimum value is obtained when sin x negative 1 becomes 0, right? So when this becomes 0, the minimum value would be 2, and the maximum value is obtained when sin x is equal to negative 1. Negative 1 added with negative 1 gives me negative 2. That is raised to the power of 2, giving us root of 8. Root of 8 is 4 times 2, so that's going to be 2 times root 2. Now you can clearly see the interval for the right hand side is 0, 2, but for the left hand side it starts from 2. The minimum value of the left hand side is actually the maximum value of the right hand side. So we would not be able to place the inequality sign here, but we can place the equality sign. So in other words, the left hand side and the right hand side will be equal at a point. So LHS is equal to RHS just at one point, and that point would be at 2, right? So this is the point in which the left hand side and right hand side will be equal to each other. So to get that equality, what should we do? In this case, to get that equality, sin x, for that to happen, let me write that down. For that to happen, sin x negative 1 should be equal to 0. That would mean sin x is equal to 1, right? Similarly, in this case, we need to get 2, right? For that to occur, sin squared y should be equal to 1, right? So only then left hand side will be equal to right hand side. Now sin squared y is equal to 1. this would mean sine y is equal to plus or minus 1. So I can rewrite this as modulus of sine y is equal to 1. Connecting left hand side and right hand side, I can clearly rewrite this as sine x is equal to modulus of sine y. So that is the original, or in other words, that is the solution. So if you were to come over here to the choice would be 4. This is the choice, right? So this is a good question, students. So we will move on to the next one. Let's do this question, students. This question occurred in JEE Mains 2021, and the question is as follows. The number of solutions of sine raised to the power of 7x positive cos raised to the power of 7x is equal to 1, with x being present in the interval 0, 4 pi is equal to. So we've been given the following choices. A is 11, B is 7, C is 5, and D is 9. So the explanation for this question is we are expected to find the number of solutions of this equation with x lying between 0 and 4. Is it 11 or 7 or 5 or 9? So that is what is required for this particular question. So foremost, what I wish to do is I would like to start off by stating, consider the equation. This is what has been given to us. Now, when exactly will this equation, or in other words, when will left hand side be equal to right hand side? So the first case is sin x should be equal to 0, and subsequently cos x should be equal to 1. This is the first case. Now the second case is, this is sin x, right? The second case is sin x should be equal to 1 and cos x should be equal to 0. So when this occurs, left hand side will be equal to right hand side. So having mentioned that, let me just head on and consider case 1. Consider case 1. When exactly sin x is going to be equal to 0? Let me write that down. When will sin x be equal to 0? Sin x will be equal to 0 when x is equal to 0, x is equal to pi, x is equal to 2 pi, x is equal to 3 pi, and x is equal to 4 pi. So this is the requirement for sin x to be equal to 0. But subsequently we should also check for cos x is equal to 1, right? Because we need to ensure that the left hand side is equal to right hand side. So for this to occur, if I were to take x is equal to 0, clearly sin x is equal to 0 and cos x is equal to 0. So that value holds good. But if I were to take x is equal to pi, sin x becomes equal to 0, but cos x becomes equal to negative 1. So this value should be dropped. But on the other hand, if I were to take x is equal to 2 pi, then sin 2 pi is equal to 0, cos 2 pi is equal to 1. So this value is dropped. And 3 pi, if I were to take 3 pi, sin 3 pi is equal to 0, but cos 3 pi would not be equal to 1. So this value should be dropped. And x is equal to 4 pi, this value will hold good. Sin 4 pi will be equal to 1, but cos 4 pi, sin 4 pi will be equal to 0, and cos 4 pi will be equal to 1. So therefore the values for which the values of, so the following would be 0, 2 pi and 4 pi. That's it. So these are the values of x for which sin x will be equal to 0 and cos x will be equal to 1. Now having got that, let us go and consider case 2. So I'm going to start by finding when will cos x be equal to 0, and subsequently sin x should be equal to 1. So when will this happen? Now, cos x is equal to 0 when x is equal to pi over 2, and when x is 3 pi over 2, 5 pi over 2, and 7 pi over 2. We can't go beyond that, right? Because that will break the given condition 0 comma 4 pi, right? So it stops there. But along with checking for cos x being equal to 0, we should also simultaneously check for sin x being equal to 1. So when will that be when will that happen? That would happen when x is equal to pi over 2. That's fine. But 3 pi over 2, the condition will fail. But for 5 pi over 2, the condition will hold good. And subsequently for 7 pi over 2, the condition will fail. So the values of x, they stop here. So therefore the values of x in this case would be pi over 2 and then 5 pi over 2. So how many such values of x have we found? Over here we got 2, over here 3. So adding 3 positive 2, we get 5. So the number of solutions of this particular equation for which x is in this interval 0 comma 4 pi is C. So this would be the right answer. C will be the right choice. So students, we will move on to the next question. Students, we have this question. This is from JEE Advanced 2014. Now this is a very interesting question. Now the question is as follows. For x contained in the interval 0 comma pi, the equation sin x positive 2 times sin 2x negative sin 3x is equal to 3, as we are expected to find the number of solutions, right? So choice A is infinitely many solutions. This is choice A. Choice B is 3 solutions. Choice C is 1 solution. And choice D is no solution, right? So we have to find the right choice. So foremost, what I wish to do is I would like to consider sin x positive 2 times sin 2x negative sin 3x is equal to 3. I would like to rewrite sin 2x as 2 times sin x cos x, and rewrite sin 3x as 3 times sin x negative 4 times sin cubed x, right, is equal to 3. This is going to be sin x positive 2 times 2 is 4, sin x cos x negative 3 times sin x positive 4 times sin cubed x is equal to 3. Now I can take sin x out. I will get a 1 positive 4 times cos x negative 3 positive 4 times sin squared x is equal to 3. I can add 1 with negative 3. That's going to be sin x of negative 2 positive 4 times cos x positive 4 times. I can rewrite sin squared x as 1 negative cos squared x is equal to 3. So this is sin x of negative 2 positive 4 times cos x positive 4 negative 4 times cos squared x is equal to 3. I can add these two together. So that would mean I will have a positive 2 and a positive 4 times cos x and negative 4 times cos squared x times sin x is equal to 3. Now if I were to take a negative sign out, this is going to be 4 times cos squared x negative 2 times cos x, and subsequently I would have a negative 2, right? So we will have to make some slight changes to achieve a perfect square. So let's do that. Now this is actually positive 4. Now if I were to write this entire term as a perfect square, this is going to be 2 times cos x, and to generate this, let us assume that I place a 1 here. So I would get, when I expand this, I get 4 cos squared x followed by negative 4 times cos x. That's fine, and I will get a positive 1. Alright, so what I will do is I will place a positive 1 here. Right, I'll place a positive 1 here. Now since there is a negative sign here, negative times this entire component would generate negative 4 cos squared x, and negative 4 cos x times negative 1 will be positive 4 cos x. Now I get a negative 1 would be coming out from here. So to get 2 here, all I need to do is place this 3 here. So place this 3 there, and that would be all it. So we will be able to actually write this in this fashion, right? So having obtained this, what I would like to do is I would like to push this 3 to the right hand side and rewrite this as 3 negative of 2 times cos x negative 1 raised to the power of 2 is equal to 3 over sin x, which is nothing but 3 times cosecant x. So we have 3 negative 2 times cos x negative 1 raised to the power of 2 is equal to 3 times cosecant x. Now this is always greater than or equal to 3, right hand side. Now the left hand side, to get the maximum value, we need to aim at getting the maximum value. Now this is only possible if this entire thing becomes equal to 0, right? So let me write that down here. So 3 negative of 2 times cos x negative 1 raised to the power of 2. This is going to be maximum only when 2 cos x negative 1 is equal to 0. So in other words, the maximum possible value that the left hand side can take, 3 negative of 2 times cos x negative 1 raised to the power of 2, would be lesser than or equal to 3. That's the last value that this particular expression can take. It cannot take anything more than that. And when would that be possible? That is possible only when 2 times cos x negative 1 is equal to 0. Now you have to observe this point. Now this is 3 times cosecant x is always greater than or equal to 3, and this is always less than or equal to 3. So left hand side will be equal to right hand side only at the point 3. Now for getting that point 3, right, we need to have 2 times cos x negative 1 is equal to 0. That means 2 cos x is equal to 1. That means cos x is equal to 1 over 2. So this is the requirement for getting 3. Now on the other end, to get 3, cosecant x should be equal to 1. So that would mean 1 over sin x should be equal to 1, which means sin x should be equal to 1, right? So this is the requirement. Now when is sin x is equal to 1? Sin x is equal to 1 when x is equal to pi over 2. But if I were to take x is equal to pi over 2 over here, cos x will be equal to 0, right? Cos 90 is 0. But cos x should be equal to 1 over 2. So that would mean we would not be able to find a value, impossible to find a value, right, that satisfies what? If I were to take this as left hand side and this as right hand side, impossible to find a value that satisfies LHS is equal to RHS. Impossible. So the solution, the choice, or I should say the exact solution for this question is D, no solution, right? So this is a lovely problem. Of course there are some logical thinking in certain part of this question. So having mentioned that, we'll move on to the next question. Students, now we are heading to type 7. In this case, the trigonometric equation will be of the form f of x is equal to square root of some phi of x. So this is the form. Now there are two steps involved in solving this type. The first step is you will have to find the domain. Find the domain of phi of x, and such that that domain should be greater than or equal to 0, because it's a square root, right? So this in turn would imply f of x is greater than or equal to 0, right? So having achieved step 1, step 2 would be we will have to take the square of the function and equate it with phi of x and subsequently solve it. That's it. So these are the steps that ought to be followed in achieving solutions to trigonometric equation of this particular form. So having mentioned this, let us do some questions. Let's do this question, students. We've been asked to solve for x such that sin x is equal to square root of 1 negative cos x, and x is contained in 0, 2 pi. So we will have to obtain the solution for this particular given equation. So foremost, let me consider sin x is equal to root of 1 negative cos x. So if I were to square both sides, I would get sin squared x is equal to 1 negative cos x. And if I were to rewrite sin squared x as 1 negative cos squared x, I would get 1 negative cos squared x is equal to 1 negative cos x. This is what I've got. Now I would like to move everything to the left. Let me use the space here. So 1 negative cos squared x, negative 1, positive cos x is equal to 0. Positive 1, negative 1 gets cancelled, giving me negative cos squared x, positive cos x is equal to 0. From here I can take cos x out. This would give me negative cos x, positive 1 is equal to 0, and which in turn is subsequently giving us cos x is equal to 0 or cos x is equal to 1. So now our objective is to find all x contained in the interval 0, 2 pi such that cos x is equal to 0. So for what values of x will cos x be equal to 0? First value is x is equal to pi over 2. The second value is x is equal to 3 pi over 2. We can't go overboard. We can't go above this because x lies in the interval 0, 2 pi. Now in this case we will have to find all x in the interval 0, 2 pi such that cos x is equal to 1. So when will that be? Now cos x is equal to 1 when x is equal to 0, and cos x is equal to 1 when x is equal to 2 pi. So we have achieved, or I should say we have obtained the values of x. Now we have to extend this result in obtaining the solution, right? We have just got the value for x for which this is true, and subsequently the values of x for which this is true. But this is not the question. The question is actually sin x is equal to root of 1 negative cos x. So for that we will have to check the domain. The domain should be 1 negative cos x should be always greater than or equal to 0, and subsequently sin x should be greater than or equal to 0. Now having got this, now it's time for us to substitute the values and perform the check. So let me start off with x is equal to pi over 2. When I substitute x is equal to pi over 2, cos pi over 2 is 0. On the right hand side I would be getting 1. So clearly the values are accepted for the right side, but the value that is produced on the right side should in turn be equal to the left hand side. And we come to know that when x is equal to pi over 2, left hand side produces 1. So that would mean left hand side is equal to right hand side. So clearly this value x is equal to pi over 2 is accepted. Now when I take x is equal to, let me write that down, accept. Now when I take x is equal to 3 pi over 2, the scenario is totally different. Now when this is substituted, the left hand side would produce -1, and clearly left hand side will not be equal to right hand side. So this has to be dropped, right? So we drop this. Now moving on, when x is equal to 0, what happens here? This would produce us 1 -1, that's 0, and this would also produce 0. So clearly x is equal to 0, we accept it. This is accepted. And when x is equal to 2 pi, what happens when x is equal to 2 pi? This is going to be positive 1, 1 minus 1 would be 0. So this would also be 0. So this will also be accepted. So we can accept this. So what are the solutions to sum it up? Okay, finally the values of x are 0, pi over 2, 2 pi. So these are the solutions. So it says that the question wants us to solve for x such that sin x is equal to root of 1 negative cos x, and x lies in the interval 0, 2 pi. And we have achieved the values of x for which the system holds good. So having mentioned that, this is a good place for us to stop. Thank you, students. We will again start off with another set of questions. Welcome, students. In this class we will be learning type 8, where questions will be involving logarithms. So as an illustration, let us head on to do this question. Log to the base 1 over 2 of mod sin x is equal to 2 negative log to the base 1 over 2 of mod cos x. So we are asked to find the number of distinct solutions and given that x is in the interval 0, 2 pi, and this occurred in JEE Mains 2020. Okay, so let us start the solution. So foremost, I wish to consider the given question: log of modulus sin x to the base 1 over 2 is equal to 2 negative log modulus cos x to the base 1 over 2. And then I would like to rewrite this as log modulus sin x to the base 1 over 2. I wish to move this quantity to the left. That would give me log modulus cos x to the base 1 over 2 is equal to 2. Now we know a formula: log a positive log b is equal to log a times b. Applying this formula, I will get log modulus sin x times cos x to the base 1 over 2 is equal to 2. We also know that if you have log a to the base b is equal to x, then a is equal to b raised to the power of x. So using this formula, this would mean I have modulus of sin x times cos x is equal to 1 over 2 raised to the power of 2. So let's move to the next page. So we have modulus of sin x times cos x is equal to 1 over 2 raised to the power of 2, right? That's what we got. If I were to square this, I would get 1 over 4, and this is going to be modulus of sin x times cos x. Now let me multiply 2 on both sides. So this would give me modulus of sin 2x is equal to 1 over 2. Right? Now if we were to remove the modulus, I have to write this as sine 2x is equal to plus or minus 1 over 2, and x is in the interval 0, 2 pi. Right? Now we will have to obtain the solution. So what I wish to do is I would like to extend the given interval by multiplying this by 2. So there's going to be 2x element of 0, 4 pi, and this is going to be, instead of that will be the next step. So let's write this down. Sine 2x is equal to plus or minus 1 over 2. Now if I were to take 2x is equal to theta, I would have sine theta is equal to plus or minus 1 over 2, with theta being contained in 0, 4 pi. Now let us just draw the graph of sine theta. Very important. Okay, so this is 2 pi, and then it comes and it hits here. So let me place the points. So at pi, and again at 2 pi, this is 3 pi, and this is 4 pi, right? And this is 0. Now we are expected to draw 1 over 2. So if you were to draw 1 over 2, so let me just take this point as 1 over 2, 1 over 2 right over there, and 1 over 2 right over there. Let me mark the point of intersection. You got a 1 here, 2, 3 and 4, and then 1, 2, 3 and 4. See the total number of solutions. So the question wants us the number of distinct solutions. So the total number of distinct solutions that we see here is equal to what? 4 in the top, 4 in the bottom is equal to 8. So this is the final solution for this particular question. That is what is required from the question. If you were to read the question wants, let me just show you the question. So if you can read the question says find the number of distinct solutions given this equation. So that is exactly what we have done. So this is a beautiful type, students, and having mentioned this, I would like to request you all to practice these types, and we will move on to the next. This is an interesting question. It was asked in JEE Mains 2021. So the question is given to be as follows. If for x element of 0, pi over 2, and that log sine x to the base 10 positive log cos x to the base 10 is equal to negative 1, and log of sine x positive cos x to the base 10 is equal to 1 over 2 times of log n to the base 10 negative 1, with n greater than 0, we are asked to find the value of n, and that we are given with the following choices. A is a 20, B is a 12, C is at 9, D is at 16. So this is an interesting question. Apparently this can be solved, though it looks a little bit complicated and complex. It can be easily solved. So foremost, what I would like to do for the solution is I would like to consider the first equation. So if I were to take this as 1 and take this as 2, let us consider 1. So what have we got? We got log of sine x to the base 10 positive log of cos x to the base 10 is equal to negative 1. Now we know that log of A positive log of B is equal to log of A times B. So by this formula I can rewrite this as log sin x times cos x to the base 10 is equal to -1. Also we know that log A to the base B, if it is equal to x, therefore A is equal to B raised to the power of x. Right, so by that we now have sin x cos x is equal to 10 raised to the power of -1, which is returned as 1 over 10. So therefore this would mean I now have sin x cos x is equal to 1 over 10. So this is the value that I have obtained. Now let me head on to consider 2. So what have I got for 2? I got log of sin x positive cos x to the base 10 is equal to 1 over 2 times of log n to the base 10 -1, and n is greater than 0. So if I were to cross multiply this to the left, this would give me 2 times of log sin x positive cos x to the base 10 is equal to log n to the base 10 -1. I wish to rewrite this. Now there is a formula. What is that? If we were to have A times log B, I can rewrite this as log B raised to the power of A. So by this formula I can rewrite this as log sin x positive cos x raised to the power of 2 to the base 10 is equal to log n to the base 10. Now 1, I can always rewrite 1 as log 10 to the base 10, right? Why? Because log A to the base A is equal to 1. So this is going to be log 10 to the base 10. So now having got this, I can rewrite this as, now there is another formula, log of A negative log of B is equal to log of A over B. So these are all formulae. So by this formula I can rewrite this as log of n over 10 to the base 10, and this is log of sin x positive cos x raised to the power of 2 to the base 10. Now we got log on both sides, so we don't cancel log. So the best phrase to use is removing log on both sides. So this is the statement you need to use. We get, so what do we get? We would get sin x positive cos x raised to the power of 2 is equal to n over 10. Now what is this? You expand this, you get sin squared x positive cos squared x positive 2 times sin x cos x is equal to n over 10. But what is sin squared x positive cos squared x? 1. Positive 2 times of sin x times cos x. What did we get? Sin x times cos x, 1 over 10. Right, so you get 1 over 10 there, right, is equal to n over 10. So let me rewrite this. This is going to be 1 positive 2 over 10 is equal to n over 10. I take the LCM, I get 10 positive 2 over 10 is equal to n over 10. Now this is 10 positive 2. 10 positive 2 is 12 over 10 is equal to n over 10. Cancelling 10 on both sides, we get the value of n to be equal to 12. So this is a beautiful question, students. I hope you understood. Thank you very much. Have a nice day. We'll move on to the next question. So this is the final type, students, and this is type 9, and in this case we would have to use the techniques of graphs in solving this question. I have an interesting question through which we will understand the concept. The question is as follows. We are expected to find the number of solutions of the equation x positive 2 times tan x is equal to pi over 2 in the interval 0, 2 pi, and we are given a list of choices. Is it 2? Is it 3? Is it 4? Is it 5? Right? So we will have to solve this question. Now before we could solve this question, we will have to, as always, I will consider the given equation. Consider x positive 2 times tan x is equal to pi over 2. Now there are a few observations we will have to make. Now this particular quantity, the expression which is on the left hand side, has got x and tan x. Now whenever we have expressions involving sin x and cos x, or sin x with tan x or cos x with tan x, we can approach the question using trigonometric identities, but in this case it wouldn't be possible. Instead of saying it wouldn't be possible, the approach would be complex. So the best way to approach this question is by graphical means. Through graphical means, we would be able to solve the question with ease, right? So that's the important part in this. So for that to occur, we will have to slightly modify the given equation. So I would place 2 times tan x on the left and I would move x to the right. So I got pi over 2 negative x. Now this particular equation can be treated as 2 different equations. So I can take this as y is equal to 2 times sin x and y is equal to pi over 2 negative x. So I've got 2 functions for which I can draw the graph. So foremost, what I would like to do is I would like to draw the graph of y is equal to tan x. Now how does the graph look? Now let me just place the axis. So there will be an asymptote. This is the graph of y is equal to tan x. There will be an asymptote at pi over 2 and at 3 pi over 2. That's fine, that's enough. And then the graph would start from 0, it will move up. So let us draw the asymptotes first. So this is the first step you got to do. You will have to plot the points and then draw the asymptotes. After you have drawn the asymptotes, you will have to then plot the points where the graph is making the intersection. So clearly between pi over 2 and 3 pi over 2, there is a hit on pi. And between 3 pi over 2, after 3 pi over 2, you have 2 pi here. So this is 0, pi and 2 pi. So make sure that you have that point there, 2 pi. So now the graph will actually, so starting from 0, so this point is 0, right? So the graph will start at 0 and it will move up like this. That's the first step of the graph. Of course, the graph will then flow down. Okay, so I don't want to draw that point. If I were to draw that point, I would have to make the subsequent markings. So having drawn the first part, coming to pi, the graph will flow from pi like this, and then it will flow down. So since pi over 2 is an asymptote, this is the way it will flow. Next, coming to the point 2 pi, the graph will of course we will have to have a asymptote there, but for this we don't need to exclusively place that. So clearly we know the graph is going to flow like this, so that's fine. And then the graph will flow down like this, right? So this is a beautiful graph for y is equal to tan x. Now you might be wondering, yes, you drew the graph of y is equal to tan x. What about y is equal to 2 times tan x? So you don't have to worry. So the intersecting points and the asymptotes will stay intact. So you don't have to worry about that. So that is the first step. Now the next step is we will have to draw the graph for y is equal to pi over 2 negative x. Now this is a straight line, right? Now since this being the straight line, we will have to take the first point. Say when x is equal to pi over 2, what happens? When x is equal to pi over 2, we get pi over 2 comma 0, right? So at pi over 2 we have an intersection. So just go and circle it up, because at x is equal to pi over 2 we get the point 0. So that would be the coordinate. So that is one particular point. Now what I wish to do is I would like to take the value x is equal to, say for example, what happens at 2 pi. Because why am I focused on 2 pi? Because the interval given to us is 0 comma 2 pi. That's the main thing. So if I were to take x is equal to 2 pi, then y will be equal to pi over 2 negative 2 pi, which is nothing but pi negative 4 pi divided by 2, which is equal to negative 3 pi over 2. So the coordinates for this is going to be 2 pi comma negative 3 pi over 2. So at 2 pi we are having a negative 3 pi over 2. So that would be somewhere over here, approximation. Now the point what we want to do is we will want to, already we got 2 points, so we will have to connect these points. So if I were to connect these points, the graph, since it's a straight line, right? So it's a straight line. So if I were to make the connectivities, the graph will flow like this. That's it. Now the most important question is you will have to find the points where the graph is intersecting with the tan x graph. Now let me just see the intersections. So clearly there is an intersection here, there is an intersection here, there is an intersection here. So 3 points of intersection. And what does the solution wants us, or I should say the question wants us? The question wants us to find the number of solutions of the equation x positive 2 times tan x is equal to pi over 2 in the interval. So without even stressing ourselves, we have obtained the solution. So in this case the solution is going to be 3, and I can specify it. Therefore the total number of distinct solutions that are possible is equal to 3. So that is the end of this particular question, and thank you. We will start off to do previous year questions. So to begin with, this is going to be JEE Advanced 2010, and it's a interesting question. We are expected to find the number of values of theta in the interval pi over 2 with the negative sign and positive pi over 2, such that theta is not equal to n pi over 5 for values of n equal to 0, plus or minus 1, plus or minus 2, and tan theta is equal to cot 5 theta, as well as sin 2 theta is equal to cos 4 theta. So the understanding is we will have to locate all values of theta which are lying in this interval, such that the theta that we are selecting has to satisfy this as well as this. That is the core of this particular question. So foremost, what I wish to do is I would like to consider the first question. So the first part of the question. So the equation that we have got here is numbered as 1 and this is numbered as 2. So let me consider 1. So from 1 I've got tan theta is equal to cot 5 theta. Now I would like to write cot in terms of tan. So this is going to be tan of pi over 2 negative 5 theta. On the left it is tan theta. So the solution in this case is going to be n pi plus alpha, right? We have already learnt about this. So this is going to be n pi plus, in place of alpha I've got pi over 2 negative 5 theta. On the left I've got a theta there. So if I were to move this 5 theta to the left, it's going to be 5 theta added with theta is going to be n pi positive pi over 2. This is 6 times theta. This is 2 times n pi positive pi divided by 2. I can take pi out. If I were to take pi out, I would get 2n positive 1 divided by 2. So theta is now 2n positive 1 times pi. 6 times 2 is 12. So this is the value for theta. Now, having obtained the value for theta, let us move on in consider 2. So what have we got? We got sin 2 theta is equal to cos of 4 theta. Now I would like to change everything to cos. So sin 2 theta can be rewritten as cos of pi over 2 negative 2 theta is equal to cos 4 theta. Right? So from here, if we were to obtain the general solution, clearly 4 theta is going to be equal to 2n pi plus or minus alpha. So alpha in this case is pi over 2 negative 2 theta. So there are two solutions that would, or two set of values that would emanate from here. One would be 4 theta is equal to 2n pi positive of pi over 2 negative 2 theta, and the other would be 4 theta is equal to 2n pi negative of pi over 2 minus 2 theta. So simplifying this, this is 2n pi positive pi over 2 negative 2 theta, and you got 4 theta here. I move this negative to the other side. This will give me 6 theta, and this is going to be 4n pi positive pi over 2, which is equal to, if I were to take pi out, this will be 4n positive 1 times pi over 2. This is for 6 theta. Therefore, if I want to get for theta, let me write down that value here. So therefore theta is going to be, I push the 6 down, so it's going to be 4n positive 1 times pi divided by 12. So I've got a value for theta here. I got a value for theta here. Now coming to this, this is going to be 2n pi negative pi over 2 positive 2 theta is equal to 4 theta. So if I were to move the 2 theta to the other side, this is going to give me 2 theta is equal to 4n negative 1 times pi over 2. Therefore I can extract theta to be as 4n negative 1 times pi divided by 4. So this is also a value for theta. Now we know that n is an element of z, right? N is element of z, and we will have to take different values of n and find out those set of thetas that are in this interval, negative pi over 2 comma pi over 2, and that would be the final end to the solution. So let's do that. Since we have run out of space, we have to move to the next page. So now the task is to find those values of theta that are present in this interval. Now the main focus is this interval. Now what I wish to do is, you can clearly see that you have a denominator 12, so I need to generate that 12 there. For that, I would be multiplying the numerator by 6 and the denominator by 6. Thereby I would now have negative 6 pi over 12 and positive 6 pi over 12. So let us consider the theta here. So theta is equal to 2n positive 1 times pi over 12. Now when I take n is equal to 1, I get 2 positive 1, that's going to be 3 pi over 12. So that's fair enough, we can take that value. Now when n is equal to 2, 4 positive 1, 5 pi over 12, we can take that value. When I take n is equal to 3, 3 times 2 is 6 positive 1, 7 pi over 12, we cannot take that value, so we will have to stop there. So we got 3 pi over 12, 5 pi over 12, and we need to take one more value. That would be for n is equal to 0. So if I were to take n is equal to 0, I would get pi over 12. So that is acceptable. So this is the first set of values that satisfy the given interval. Now, having taken the positive side, we will also cater to the negative side. So when n is equal to negative 1, that would give me negative 2 positive 1, that's negative 2, so it's going to be negative pi over 12, that's fine. When n is equal to negative 2, negative 4, negative 3 pi over 12. When n is equal to negative 3, negative 6 and negative 5 pi over 12, that's fair enough. When n is equal to negative 4, I will get negative 7 pi, that's not acceptable. So the set of values for theta in this case, let me write that down. I've got pi over 12, 3 pi over 12, 5 pi over 12, negative pi over 12, negative 3 pi over 12, negative 5 pi over 12. Okay, that's done. Coming to the next set, okay, which is theta. Okay, this is the next one. Theta is equal to 4n positive 1 times pi over 12. So when n is equal to 0, okay, when n is equal to 0, what do we get? When n is equal to 0, we get pi over 12. That's fine. When n is equal to 1, we get 5 pi over 12. That's fine. When n is equal to 2, 8 pi. No, we need to drop that. So the count stops here. Similarly, when n is equal to negative 1, what do I get? When n is equal to negative 1, I get negative 3 pi over 12, that's acceptable. When n is equal to negative 2, negative 2 is negative, no, it's giving us negative 7 pi over 12. So the set of values are pi over 12, 5 pi over 12 and negative 3 pi over 12. So these are the set of values that we have got. Okay, now moving on to the last set. So let me draw a line. So we got theta is equal to 4n negative 1 times pi over 4. Now the theta has to be present within the interval negative pi over 2 comma pi over 2. So I would like to change it so that it includes the denominator 4. So multiply the numerator by 2 and the denominator by 2, and we would have a new differentiation for the interval. So now theta should be negative 2 pi over 4 and positive 2 pi over 4. There aren't any changes at all, right? So you're still going to get negative pi over 2, positive pi over 2. I just want to make sure that the interval is more appropriate to what we are actually looking at, because it gives us some level of ease in calculating the value and then in isolating those values which we really want. Okay, so having mentioned that, let me just start off. So when n is equal to 0, we get the following. This is going to be negative pi over 4. That's the value that we get when n is equal to 0. So that's okay, right? Now when n is equal to 1, we get 3 pi. We get 3 pi over 4, right? Now clearly this cannot exist, right? For the given fact that the interval is actually negative 2 pi over 4 to positive 2 pi over 4. So this cannot occur. Now negative pi over 4, if you were to check the solutions, this is actually present here. Negative 3 pi over 12 is nothing but negative pi over 4. So we don't even also need this. So we can actually drop this. So therefore the list of solutions for this theta is going to be pi over 12, 5 pi over 12 and negative 3 pi over 12. But this is not the end of the story. Why is it not the end of the story? Because we would have to find out the theta that are actually common among the first set and the last set. Take those values and plus those values which are unique, right? So that is the final completion to this particular question. So that's exactly what we are going to do. So now let's do that. Now since we were looking for those theta which satisfy both the equation, we will only are required to take those values which are common between these two sets of thetas. So clearly pi over 12 and pi over 12 is common, so I can write that. This is the final solution. So let me write that down, pi over 12, and we have got 5 pi over 12, 5 pi over 12 common, 5 pi over 12, and then finally negative 3 pi over 12 and negative 3 pi over 12. That's also common. So these are the set of thetas that satisfy the given system. So this would mean the total number of solutions are equal to 3. Right, so this completes the solution set for this given question. Students, let's do this question. We have been given let S to be equal to collection of all x such that x lies between the interval negative pi and pi, and such that x is not equal to 0 and plus or minus pi over 2. So we are expected to find the sum of all distinct solutions of the equation root of 3 times secant x positive cosecant x positive 2 times of tan x negative cot x is equal to 0. And we have given a list of choices. We are given choice A, is it 7 pi over 9, B, is it negative 2 pi over 9, C, is it 0, D, is it 5 pi over 9, right? So foremost what we have to do is, let us start off by considering the given question. Now this has been asked in JEE Advanced 2016. Okay. So consider root of 3 secant x positive cosecant x positive 2 times of tan x negative cot x is equal to 0, right? Now I wish to convert secant x into cos x. So this can be rewritten as root of 3 divided by cos x. Cosecant x I would like to write it as sin x, and 2 times tan x, let us write it as sin x over cos x, and cot x is cos x over sin x is equal to 0. Now let me take the LCM for this, which is sin x times cos x. This would give me sin squared x minus cos squared x times 2, and if I were to take the LCM for this, sin x cos x, this will give me root of 3 times sin x plus cos x, right? This is what I would get. Now what we can do is we can actually perform some slight modifications by taking sin x cos x as a common factor. So taking 1 over sin x cos x out, I would get root of 3 times sin x positive cos x positive 2 times of sin squared x negative cos squared x is equal to 0. Now this can cross multiply and thereby leave us with root of 3 times sin x positive cos x positive 2 times sin squared x negative cos squared x is equal to 0. Now I would like to divide by 2 throughout. So this is by 2, this is 2, this is 2, this is 2. So this is going to give me root of 3 over 2 sin x positive 1 over 2 times cos x positive this 2 in the denominator and the 2 in the numerator will be cancelled, giving me sin squared x negative cos squared x. So let me write that down. Sin squared x negative cos squared x is equal to 0. I would like to push this to the other end. That would give me cos squared x negative sin squared x. On the left hand side I have root of 3 over 2 times sin x positive 1 over 2 times cos x. Now this can be rewritten as sin pi over 3, right? Sin pi over 3 is nothing but sin 60. Sin 60 is root 3 over 2 times sin x positive cos pi over 3. Cos pi over 3 is cos 60 is 1 over 2 times cos x. Now this can be rewritten as cos of, now we can use the cos formula, right? Cos A, cos B, negative sin A, sin B. So that is what I would be using. If I were to use that, I can rewrite this as cos of x negative pi over 3, right? This expression or this identity would generate this. On the right hand side I have cos squared x negative sin squared x, which is going to be cos 2x. So this is cos 2x. Now let us obtain the general solution, right? So if I were to obtain the general solution, I can rewrite this as x negative pi over 3 is equal to 2n pi plus 2x on one side, and then x negative pi over 3 is equal to 2n pi negative 2x. So this is on the other side. So now we have to extract the value of x. So what I wish to do is probably I will use the next page to complete the question. So now we got this, we have to extract the value for x. So I wish to move this 2x to the left side. So it's going to be x negative 2x is equal to 2n pi positive pi over 3. This is negative x 6n pi positive pi over 3. And I can rewrite this as 6n positive 1 times pi over 3. This is actually negative x, so I can place a negative sign here, and that would be the value for x. Probably if you want, you can take the negative sign inside. So having got this, let's move to the other x. So from here I move negative 2x to the left, so it's going to be x negative pi over 3 positive 2x is equal to 2 and pi. I can add these two together, giving me 3x. I can move this pi over 3 to the other side, so this is 2 and pi positive pi over 3. If I were to take the LCM as 3, this is 6 and pi positive pi. If I were to rewrite this, this is going to be 6n positive 1 times pi over 3. On the left I got 3x. So therefore I can write x to be as 6n positive 1 times pi divided by 9. So this is what I've got for the second x. So now it's time for us to take the values for n and obtain the corresponding x's. So for that we will have to find the interval. The interval is given to be as negative pi comma pi. Now I've got a 3 here, so what I wish to do is I would like to multiply the numerator by 3, divide the denominator by 3, or I should say multiply the numerator and denominator by 3. I think that's the best way to say. So x is the element of negative 3 pi over 3 comma positive 3 pi over 3. So this is what I've got. So having got this, let me extract the values for x for varied values of n. So when n is equal to 0, I get 0 there, so it's going to be negative pi over 3. When n is equal to 1, it's going to be 6 positive 1, 7 pi over 3. 7 pi over 3 we would not be able to accommodate, because that would have a conflict with the interval. So negative 7 pi over 3 is not, it has to be dropped. Now for the negative side, when n is equal to negative 1, I get negative 6 added over 1 would give me negative 5 pi over 3. Negative 5 pi over 3 should also be dropped. So ultimately we just have to be content with one value of x. Okay, so moving on, in this case I got a 9 here, and x is contained in the interval negative pi comma pi. So what I wish to do is I would like to multiply by 9 and divide by 9, 9 and 9. So when n is equal to 0, I get pi over 9. When n is equal to 0, I get x is equal to pi over 9. That's fine. And when n is equal to 1, I get 6, 1, 7 pi, right? 7 pi over 9. And then when n is equal to 2, 6 times 2 is 12, 12 plus 1, 13. That's not possible. When n is equal to, this is 0 and 1. When n is equal to negative 1, negative 6, that's going to give me x to be as negative 5 pi over 9. When n is equal to 2, negative 2, negative 12 added with 1, negative 11. So that has to be dropped. So this is the set of values that we have obtained. Now we got to actually get the sum for these values. So that's exactly what we have to do now. So now we got to obtain the sum. So let's calculate the sum. So we got negative pi over 3 added with pi over 9 added with 7 pi over 9 and then followed by negative 5 pi over 9. So if I were to take the LCM as 9, this would give me negative 3 pi followed by pi, 7 pi and negative 5 pi, right? So I can add pi with 7 pi, that's going to be 8 pi, and I can add negative 3 pi with negative 5 pi, that's going to be negative 8 pi divided by 9. which is equal to 0. So this is the solution to this question, students. And if we were to go by the choice, let me show you all the choice. So the choice in this case would be C. Right, clearly you can see that this is the right choice. So having completed this, we are finished this topic on trigonometric equations, students. Thank you. Students, we got another question. We will be working this question. It occurred in JEE 2019. So having mentioned that, let's start the question. We expected to find the sum of all values of theta which is lying in the interval 0, pi over 2 and satisfying the equation sine squared 2 theta positive cos raised to the power of 4 2 theta is equal to 3 over 4. We have 4 choices. The first choice is pi over 2, the second choice is pi, the third choice is 3 pi over 8, the fourth choice is 5 pi over 4. So which of these choices do you think is the right answer for this question? Of course, we cannot make any guesses in this case, and the reason is the probability of getting the right answer is stacked against us if we are going to be making guess and making the choice. So the best way is to solve it. So what I am going to do is I am going to start off by considering the given trigonometric equation, which is sine squared 2 theta positive cos raised to the power of 4 2 theta is equal to 3 over 4. Now what I wish to do is I would like to write sine squared 2 theta as 1 negative cos squared 2 theta and cos raised to the power of 4 2 theta as cos squared 2 theta raised to the power of 2, right? And this is equal to 3 over 4. So this looks nice, but the only thing is that we will have to make some simplification. So I would start off by writing this cos squared 2 theta raised to the power of 2 followed by negative cos squared 2 theta and positive 1. Now I got a 3 over 4. Let me bring this 3 over 4 here and rewrite this. So this is going to be cos squared 2 theta raised to the power of 2 negative cos squared 2 theta 1 negative 3 over 4 will give me 1 over 4 is equal to 0. Now this is a perfect square. Now I can write this as cos squared 2 theta negative 1. Now if I were to do that, there is one particular problem. What is the problem? We got a 1 over 4 there. So our perfect square would hit the wall if we are going to have this 1 over 4 and still express it. So what I wish to do is I would like to take this 4 as the LCM. So if I were to take this 4 as the LCM, then I would end up with 4 times of cos squared 2 theta raised to the power of 2 followed by 4 times cos squared 2 theta positive 1 is equal to 0. That 4 will get absorbed. Now I would like to rewrite this as 2 times cos squared 2 theta raised to the power of 2 followed by negative 2 times of 2 cos squared 2 theta positive 1 squared is equal to 0. So now this is well set to be expressed as a perfect square. I'm going to write this as 2 times cos squared 2 theta negative 1 raised to the power of 2 is equal to 0. If I were to expand this, this is going to be 2 times cos squared 2 theta raised to the power of 2. I get the first term. Negative 2 times of 2 times cos squared theta 2 theta, that's going to be the second term. Positive 1 squared. So this is fantastic. Now from here I can rewrite this to be as 2 times cos squared 2 theta negative 1 is equal to 0, which means 2 times cos squared 2 theta is equal to 1, which means cos squared 2 theta is equal to 1 over 2, which I can rewrite this as cos pi over 4 raised to the power of 2, but we can also write it as cos squared pi over 4. So now we have cos squared 2 theta is equal to cos squared pi over 4. So this is very similar to the one we studied, cos squared x is equal to cos squared alpha, when we were talking about the general solution. And from here the general solution is going to be 2 theta is equal to n pi plus or minus pi over 4. So this would mean my theta would be equal to n pi over 2 plus or minus pi over 8. Now we can't take all the values of theta. We can only take those values of theta which are in this interval 0 comma pi over 2. So let me just check that out. I just want to finish the question on this side. So when n is equal to 0, I get theta to be equal to plus or minus pi over 8, but I can take only positive value because of the given interval. So pi over 8 is there. This is for n is equal to 0. Now let me take n is equal to 1. When n is equal to 1, I get two values, pi over 2 plus pi over 8. So let me just check this out. This is going to be 8, right? 4 pi positive pi, this is going to be 5 pi over 8, right? So 5 pi over 8, and then when n is equal to, we also need to look into the other one. So pi over 2 negative pi over 8, right? So this is going to be equal to 8, 4 pi negative pi. This is going to give me 3 pi over 8. Now I don't have to use 5 pi over 8 and 3 pi over 8. I can very well use these things, but the much important question is, of these two, which one is accepted for the given interval 0 comma pi over 2? That is the deciding factor. Now 5 pi over 8 is equal to 112.5 degrees and 3 pi over 8 is equal to 67.5 degrees. But our theta should lie between 0 and pi over 2. So naturally this has to be dropped because of the fact 5 pi over 8 is 112.5 degrees and this is taken. 3 pi over 8 is 67.5 degrees. But when I'm expressing it, or when I'm using them, I wouldn't be using 3 pi over 8. I would like to use this in this fashion, pi over 2 negative pi over 8. Now there's no point in heading further because n is equal to 2. If n is equal to 1 is producing this, n is equal to 2 is going to be producing greater value. So there's no point in going further. So our theta is already obtained from n is equal to 0 and n is equal to 1. The question wants us to find the sum of all values of theta. So therefore the sum is equal to, when n is equal to 0 I get pi over 8. When n is equal to 1 I have received pi over 2 and negative pi over 8. So clearly what we can see, pi over 8 and negative pi over 8 gets cancelled, giving us pi over 2. So the choice, let's go and see the choices. The first choice is pi over 2 and our focus and our eyes should only meet this. We don't have to go anything further. So this is the right solution. So that is the solution for this particular question, students. Thank you. We'll move on to the next one. Students, we got a beautiful question, and the question reads as follows. Let theta 1 and theta 2, where theta 1 is less than theta 2, be the solutions of 2 times cot square theta negative 5 over sine theta positive 4 is equal to 0, where theta is said to be present in the interval 0, 2 pi. Now we are expected to find integral theta 1 to theta 2 of cos square 3 theta times d theta, and we have the following choices. A is pi over 9, B is 2 pi over 3, C is pi over 3 positive 1 over 6, and D is pi over 3. So this question occurred in JEE 2020 mains, right? So this is the question, and we are expected to solve this. Now, of course, there is an integral that we have to evaluate, but this is a trigonometric equation. So foremost, what I wish to do is I would like to start by considering 2 times cot square theta negative 5 over sine theta positive 4 is equal to 0. Now I would like to rewrite this as 2 times cot square theta. 1 over sine theta is going to be cosecant theta, right? Positive 4 is equal to 0. Now since I've used cosecant theta, we know that the following formula. What is that? Cosecant square theta negative cot square theta is equal to 1, which in turn will imply that cosecant square theta negative 1 is equal to cot square theta. Now what I'm going to do, I'm going to replace this formula over here. So this is going to be 2 times of, in place of cot square theta, it's going to be cosecant square theta negative 1 followed by 5 times cosecant theta positive 4 is equal to 0, right? So distributing 2, I get 2 times cosecant square theta negative 2 negative 5 times cosecant theta positive 4 is equal to 0. I would like to rewrite negative 5 times cosecant theta as 4 times cosecant theta followed by negative cosecant theta. 4 added with 2, negative 2 would give me positive 2 is equal to 0. So from here I would like to take 2 times cosecant theta out. That would give me cosecant theta negative 2. If I were to take negative 1 out, I would get cosecant theta negative 2 is equal to 0, right? Now cosecant theta negative 2 is common, it's taken out, so this is going to give me 2 times cosecant theta negative 1 is equal to 0. From here I get cosecant theta negative 2 is equal to 0, and 2 times cosecant theta negative 1 is equal to 0. From here 2 times cosecant theta is equal to 1, cosecant theta is equal to 1 over 2. This means 1 over sine theta is equal to 1 over 2, therefore sine theta is equal to 2, which is not possible, so we have to drop this. Now coming to this part, from here I can write 1 over sine theta minus 2 is equal to 0, 1 over sine theta is equal to 2, therefore sine theta is equal to 1 over 2. Now I am given that theta lies between 0, 2 pi. So if I were to draw the graph of sine, so it starts here, goes up, and this is 0 to 2 pi. Now I've got sine theta is equal to 1 over 2. So if I were to draw the line, this would be the line. So there is a intersection here. is the intersection here. So this point will be pi over 6. This intersection is going to be 5 pi over 6. We clearly know that. So this means we got theta 1 is equal to pi over 6 and theta 2 is 5 pi over 6. Now since theta 1 is less than theta 2, it's given, right? This would mean integral theta 1 to theta 2 of cos squared, this is the one we got to find out. Cos squared 3 theta d theta is equal to integral pi over 6 to 5 pi over 6 of cos squared 3 theta d theta, right? So cos squared theta is equal to 1 positive cos 2 theta divided by 2. So therefore cos squared 3 theta is equal to 1 positive cos 6 theta divided by 2, right? So this is equal to integral pi over 6 to 5 pi over 6 1 positive cos 6 theta divided by 2 times d theta, right? So this is going to be 1 over 2 integral pi over 6 5 pi over 6 d theta positive cos 6 theta d theta, right? So we got an integral and 1 over 2 is common, so pi over 6 to 5 pi over 6. So if I were to integrate this is going to be 1 over 2 times integral of theta, d theta is going to be theta. The limits are pi over 6 to 5 pi over 6 positive integral of cos 6 theta sin 6 theta divided by 6. Limits are pi over 6 to 5 pi over 6. So this is equal to 1 over 2 times. I substitute the upper limit, that's 5 pi over 6 negative pi over 6. For this I substitute the upper limit, 1 over 6 I can take it out. So sine 6 times 5 pi over 6 minus sine 6 times pi over 6. Now 6 gets cancelled, sine 5 pi that vanishes, 6 gets cancelled, sine pi that vanishes. So all I'm left with 1 over 2 times 6 5 pi negative pi, which is equal to 1 over 2 times 5 pi negative pi is 4 pi divided by 6. So 2 divides 4 2 times, 2 divides 6 3 times. So the solution is pi over 3 units. So that is the solution for this question, students. I hope you enjoyed this question. So that completes our study. Welcome students, we have another question. This is from JEE Main 2021. The question is as follows. If n is the number of solutions of the equation then S being the sum of all solutions such that the ordered pair n comma s is what? Now n is the number of solutions, right? And s is the sum of all those solutions. So we have been given the following choices: 3 comma 13 pi over 9, b is 2 comma 2 pi over 3, c is 2 comma 8 pi over 9, and d is 3 comma 5 pi over 3. Let me just specify the system. Equation is given to be as 2 times cos x of 4 times sine of pi over 4 positive x multiplied with sine of pi negative 4 times x negative 1, right, equal to 1, such that x is contained in the interval 0, pi. So this is the system that is given, and when we are talking about n is the number of the solutions of the equation. So this is the required equation, and the n that we are dealing with indicates the number of solutions that this equation produces, right? So having made that statement, let me consider the given equation. So this is 2 times cos x of 4 times of sine of pi over 4 positive x times sine of pi over 4 negative x negative 1, right? So this is further given to be equal to 1. Now we have a formula, sine of theta or sine of a positive b times sine of a negative b can be written as, this can be written as 4 times of sine squared of pi over 4 negative sine squared of x. I can always write it like this. So this is there, followed by a negative sign and a huge parenthesis times 2 times cos x is equal to 1, right? Now sine squared pi over 4, right? What is that? Sine squared pi over 4 is 1 over 2. So I can substitute that. So this is 2 times cos x of 4 times of 1 over 2 negative sine squared x followed by a negative 1 equal to 1. So that's fine. So 4 is distributed inside, will give me 2 negative 4 times of sine squared x followed by a negative 1 is equal to 1. This is 2 times of cos x. Now sine squared x, I'm going to write it as 1 negative cos squared x negative 1. There's already a 2 there, and this is equal to 1 with the product multiple of 2 times cos x. So I can rewrite it as 2 times cos x of 2 negative 4 positive 4 times of cos squared x and then a negative 1. So I've got 2 negative 4, that's negative 2 added with 1 gives me negative 3, right? So I can write that plus, let me write it like this, 4 times cos squared x followed by a negative 3 is equal to 1. I got a 2 times cos x here. I'm going to divide by 2. So if I divide by 2, I would get cos x of 4 times cos squared x negative 3 is equal to 1 over 2. So that's a better way to get rid of this 2. So this can be further rewritten as 4 times cos cubed x negative 3 times cos x is equal to 1. Now what is this? This is nothing but cos 3x is equal to 1. Actually, this is 1 over 2, right? So we got a beautiful equation such that x is contained in the interval 0, pi. Now what I wish to do, I wish to multiply this by 3. So this is 3x is contained in 0, 3 pi. And this is going to be cos 3x is equal to 1 over 2. I can take theta to be equal to 3x. So that would mean I now have cos theta is equal to 1 over 2 such that theta is contained in 0, 3 pi. Now if I were to draw the graph, cos starts from here, goes up, goes down, comes up and then goes up, right? This is the cosine. This is the cosine graph. So this is 0, and when theta is equal to 0, we get cos 0 is 1, where this is going to be pi. This is negative 1, this is pi, and this is 2 pi, this is 3 pi, right? Now cos theta is this. Now we got 1 over 2, that's a constant. So 1 over 2 means if I were to draw 1 over 2, I will have to stretch all the way up until this is 2 pi and this is going to be 3 pi. Right? If I were to stretch it, I will have to stretch it all the way up until this point. So this is 1 over 2. So if I were to draw the line 1 over 2, it will be going up all the way till here. Now what is the point of intersection? That is important, right? That gives us a solution. I got 1 here, 2 here and 3. That's it. So 1, 2 and 3. So there are 3 solutions. So total number of solutions is equal to 3, right? But the question is, what are those solutions? We need to know. So mean theta is equal to pi over 3. So this point is clearly pi over 3. Now this point is going to be 5 pi over 3 and clearly this point is going to be 7 pi over 3. So the sum of all these points, so pi over 3, positive 5 pi over 3, positive 7 pi over 3, this is going to be pi, positive 5 pi, positive 7 pi. So this has to be divided by 3 and this is going to give us 12, 13 pi divided by 3. But this is actually for theta, but we would require x. So therefore if you are requiring for x, we would have to take it like this, because theta is 3x, like 3x is equal to 13 pi over 3. Therefore x is going to be 13 pi divided by 9. So when it comes to the sum, right, this should be the accepted answer. So the ordered pair, therefore the ordered pair equals 3, 13 pi over 9. So that would mean the choice given to us is 3, 13 pi over 9. So this should be the choice. Right, so that completes the solution to this question. Students, let's do this question. This question was asked in JEE Main 2021. So the question is as follows: the number of solutions of the equation 32 raised to the power of tan squared x positive 32 raised to the power of secant squared x is equal to 81, x lying between 0 and pi over 4 is what? So we are expected to find the number of solutions of this equation, right? So we are given A to be as 3, B as 1, C as 0 and D to be as 2. So this is what we have now. So let us consider the given system, which is 32 raised to the power of tan squared x positive 32 raised to the power of secant squared x is equal to 81. Now we know that secant squared x negative tan squared x is equal to 1. Therefore I can write secant squared x as 1 positive tan squared x, right? So having got that, I would like to substitute in place of secant squared x 1 positive tan squared x. So this is going to be 32 raised to the power of tan squared x positive 32 raised to the power of 1 positive tan squared x is equal to 81. Now we know that a raised to the power of m positive n is equal to a raised to the power of m times a raised to the power of n. So I can rewrite this as 32 raised to the power of tan squared x positive 32 raised to the power of 1 times 32 raised to the power of tan squared x is equal to 81. Now I can take 32 raised to the power of tan squared x as a common factor. That would give me 1 positive 32 is equal to 81. Now this can be rewritten as 32 raised to the power of tan squared x times 33 is equal to 81. I can push 33 down, so I have 32 raised to the power of tan squared x is equal to 81 divided by 33. Now taking log to the base 32, we get, so what do we get? This is log 32 raised to the power of tan squared x is equal to log of 81 divided by 33. Now we know that log a raised to the power of b is b times log a. So that would mean I now have tan squared x times log 32 is equal to log 81 divided by 33. But this is to the base 32, base 32, base 32, base 32. Now we know that log a to the base a is equal to 1. So because of that, this would mean log 32 to the base 32 is equal to 1. So this is equal to 1. So I now have tan squared x is equal to log of 81 over 33 to the base 32. So this is nothing but tan x is equal to root of log of 81 over 33. Now this value will be between 0 and 1. Okay, but our x lies between 0 and pi over 4. So this would mean in this given interval for x, there can be just one solution. So this implies the choice is B. So that is the end of this particular question. Students, we'll move on to the next one. Students, we have a beautiful question. This question was asked in JEE Mains 2021. Now the question is as follows. If sin theta positive cos theta is equal to 1 over 2, then we are asked to find the value of 16 times sin 2 theta positive cos 4 theta positive sin 6 theta, right? The entire parenthesis. So we expected to get this value, and all we are given is sin theta positive cos theta is equal to 1 over 2. So let us do that. No, also let me just list down the choices. We have choice A 23, choice B negative 27, choice C negative 23, and choice D is 27. So if you are not able to know the solution, then it's difficult to make the choice, because you have a 50% probability stacked against you. So because you have a 23 with a negative sign, 23 with a positive sign. So we will do it mathematically. So we are given this question, and as always I will start off by considering sin theta positive cos theta. This is what is given, right? So I'm taking the square on both sides. So squaring both sides, we get, so what do we get here? This is sin square theta positive cos square theta positive 2 times sin theta cos theta is equal to 1 over 4. We know that, what do we know? Sin square theta positive cos square theta is equal to 1, right? By formula, by trigonometric identity. So I'm going to place 1 there, followed by 2 times sin theta cos theta is equal to 1 over 4. I'm moving this 1 to the other side. So this would mean I have 2 times sin theta cos theta is 1 over 4 minus 1. If I were to take the LCM as 4, this is going to give me 1 negative 4, which is negative 3 over 4. Right? But 2 times sin theta cos theta is what? Sin 2 theta. So this means sin 2 theta is equal to negative 3 over 4. This is what I will be using to get the output. Right? Now I've got sin 2 theta already. I need to get cos 4 theta. So let's write cos 4 theta. Now I would like to write cos 4 theta as cos of 2 times of 2 theta. Now cos 2 theta as a formula, right? Cos 2 theta, I can always write cos 2 theta in this fashion. Say for example, if I were to write this as cos squared 2 theta negative sine squared 2 theta, I can just head on and replace cos 2 theta as 1 negative sine squared 2 theta followed by sine squared 2 theta. So this is going to be equal to 1 negative 2 times sine squared 2 theta, right? So this is what I've got, 1 negative 2 times sine squared 2 theta, which is nothing but 1 negative. Sine 2 theta is negative 3 over 4. This has to be raised to the power of 2. So this is going to be 1 negative 2 times 9 divided by 16, which is equal to 1 negative 18 over 16, which is equal to 16 negative 18 over 16, which is negative 2 over 16. This is what I have got, negative 2 over 16, which can be subsequently reduced to negative 1 over 8. So what is this? This is my cos 4 theta, right? So that is done. Next, coming to sine 6 theta. Now consider sine 6 theta. Now sine 6 theta can be written as sine 3 of 2 theta. So this is sine 3 theta is what? Sine 3 theta is nothing but 3 times sine theta, right? That's the formula. In this case, in place of theta, I've got 2 theta minus 4 times sine cube theta. This is the formula. So if I were to take sine 2 theta out, this is going to give me 3 negative 4 times sine squared 2 theta. Now sine 2 theta is obtained to be as negative 3 over 4 times 3 negative 4 times of negative 3 over 4 raised to the power of 2. Right, now we have to simplify this. So this is equal to negative 3 over 4, 3 negative, 3 3s are 9, and I got a 9 and a 16, right? So which is equal to negative 3 over 4, 4 divides here 4 times, so it's going to be 9 over 4, which is nothing but negative 3 over 4 of 12 negative 9 divided by 4, which is negative 3 over 4 of 3 over 4, right? 12 negative 9 will give you 3 over 4. So this is nothing but negative 9 over 16. This is what you've got. That's absolutely correct, negative 9 over 16. Now the point is, we will have to extract this value. We will have to obtain this value, right? This is equal to what? This is what we are expected to find. So I would like to finish this off within this page. I don't want to move to the next page. So I'm trying to, probably I will use this space over here. I will try to squeeze everything inside this. So this is equal to 16 times sine 2 theta, right? Sine 2 theta. Sine 2 theta is negative 3 over 4. Positive cos 4 theta. Cos 4 theta is negative 1 over 8. So negative 1 over 8, and cos sine 6 theta. Sine 6 theta is negative 9 over 16. So this is what I've got, 9 over 16. So I want to take a negative sign out. If I were to take a negative sign out, this will be negative 16. Let me take 16 as the LCM. This is going to be negative 12. This is going to be negative 2. This is going to be negative 9. This is 16 gets cancelled, right? So 12 added with 9, of course you will get 21 with a negative sign. Added with negative 2, you will get negative 23, but there is a negative sign here. Negative, positive, that's going to be 23. So that is the right choice. 23 is the right choice, so we got it. Now, of course, I know that this is not, you cannot take this to be completely trigonometric equation section, because they are only asking us to evaluate this. Of course, this is an equation, trigonometric equation, but just to be consistent in the approach, probably we can include it. But anyway, since it is a previous year question paper, I have done it. I know certain people would think that this is too simple to be included in trigonometric equation, but this has featured, right? We cannot make any judgments whether to include or to exclude, but all we need to do is to just run the race, right? So as I mentioned to you, I have completed a list of a few examples with regard to the previous year question papers. That is done basically to add more weightage to the content, so that the viewer gets a rounded substance of what trigonometric equation is and what to exactly look forward to, right? But having mentioned that, for any competitive examination, it is imperative to know that nothing is too much. So in other words, no matter how much you work on it, everything is too little. So that is the idea that you should have. So the point is that you should consistently keep grinding on your mission. That's the best way to put things in perspective. In other words, say if someone were to tell you that, okay, you are doing, say, 200 questions on trigonometry equation, and that is sufficient enough, and you would be able to have a cakewalk. If you are going to go with that attitude, then means you will always fall short with somebody who had gone beyond 200. That's the simplest thing I can say. So no matter how much you do, it isn't enough until the day of the examination. So you need to have that that level of mindset to be consistently working non-stop, right? Because it's a competitive examinations, and competitive examinations have this habitual act of bringing things to challenge the candidates, right? Because the ulterior motive is what? Is to filter, because only the best can get into it. Having mentioned this, let me just wind up with this note that consistency is the key. Along with that, keep doing problems. Keep doing problems. The more you do, the better. Thank you, students. So until we meet again with the next topic, take care.